Hello and welcome to a new lesson on Vagrant. In this lesson, we will explore what Vagrant is, its benefits, and its diverse use cases. By the end of this lesson, you will have a comprehensive understanding of how Vagrant can enhance your learning and development process. Before we delve into the world of Vagrant, let's define virtual environments and understand their profound significance in modern development practices. Virtual environments are self-contained software containers that allow you to install and manage different software versions and configurations without affecting your host machine. They play a crucial role in ensuring a consistent and isolated development environment, preventing conflicts between projects and ensuring your code runs flawlessly across various machines. Now that we have established the importance of virtual environments, let's introduce Vagrant, a powerful tool for creating and managing virtual development environments. Vagrant simplifies the process of provisioning and managing virtual machines, making it effortlessly easy to set up and maintain consistent development environments. Vagrant's key features include easy provisioning. Vagrant supports various provisioning tools such as shell scripts, Chef, and Puppet, enabling automated configuration of your virtual machines. Portability. Vagrant files can be easily shared and used across different operating systems and virtualization platforms. Resource efficiency. Vagrant utilizes lightweight virtual machines, minimizing the impact on your local machine's resources. Reproducible environments. Vagrant ensures that your development environment remains consistent across different machines and developers. Vagrant offers numerous benefits that make it an indispensable tool for developers. Let's explore the top 5 reasons why you should use Vagrant in your development workflow. Vagrant's benefits include reproducible environments. Eliminate the dreaded works on my machine issue by ensuring consistent development environments across different machines and developers. Simplified collaboration. Share your development environment seamlessly with others, facilitating collaboration and ensuring consistent results among team members. Portability. Easily transport and use Vagrant files on different operating systems and virtualization platforms, promoting portability and consistency across environments. Automation. Utilize Vagrant support for various provisioning tools to automate the configuration and setup of your virtual machines, saving time and effort. Resource efficiency. Leverage Vagrant's lightweight virtual machines to minimize the impact on your local machine's resources, enabling you to run multiple environments simultaneously. The versatility of Vagrant extends beyond simple development environments. It finds its applications across a diverse range of scenarios, including web development. Set up consistent and reproducible development environments for web applications. Testing and deployment. Utilize Vagrant to create controlled environments for testing and deploying applications, allowing you to reproduce production-like scenarios locally. DevOps and infrastructure management. Widely used in DevOps practices to manage infrastructure components and automate provisioning tasks. Learning and experimentation. Empower developers to experiment with different software configurations and technologies without affecting their local machine. Cross-platform compatibility. Facilitate cross-platform development and testing, allowing you to build and test applications on various operating systems. Vagrant has revolutionized the way developers work by providing consistent, portable, and reproducible environments. And by that, we get to the end of this lesson. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson. This lesson will be a short one which will guide you through our course repository and where to find the instructions needed to install VirtualBox and Vagrant on various operating systems. So first, let's go to the course repo on GitHub. So the URL for the repo is github.com/linux-mastery-real-world-job-simulation-projects. I will add the repo URL as a note to this lesson. In the repo, you will find project folders which have Vagrant files and bash scripts for each project. We will talk about them later. For now, let's focus on the docs folder. Let's click it. From the docs folder, you can find instructions to install VirtualBox and Vagrant on Windows, Ubuntu, and Red Hat family. Open the instruction you want for your operating system and follow it. In case you have any questions or problems, please don't hesitate to ask in the discussion. I hope you enjoy this course as much as I do. Thank you for watching and see you in the next lesson. Hello and welcome to our lesson on essential Vagrant commands. In this lesson, we will delve into 3 fundamental commands that are vital for managing virtual environments in Vagrant. Whether you are a beginner or looking to refresh your skills, this lesson is tailored for you. Let's begin with Vagrant up. This command is your starting point in the world of Vagrant. When you type Vagrant up in your terminal, Vagrant leaps into action. It reads your Vagrant file, prepares the virtual machine, and boots it up. This process may take a little time, especially if it is downloading the box image for the first time. Let's press enter to execute the command. And as I mentioned, this process may take 2 to 5 minutes or more, depends on the instructions inside the Vagrant file. So I will pause the video and I will come back once Vagrant finishes its work. As you can see, I didn't get any error message, which is a good sign that Vagrant up finished its work. Next, let's explore Vagrant halt. Imagine you have finished your work and want to shut down your virtual environment safely. Just type Vagrant halt. This command sends a signal to the virtual machine to initiate a safe and graceful shutdown. It is similar to shutting down your personal computer. Now press enter and wait for the process to complete. This ensures that all your data is saved and the machine state is preserved correctly. Now, if you want Vagrant to run the virtual machine again, execute Vagrant up again. Finally, we have Vagrant destroy. This command is used when you want to completely remove the virtual machine and its resources from your system. So, to delete the virtual machine from your system, just type Vagrant destroy and press enter. Be cautious with this command. Once executed, Vagrant destroy removes the virtual machine along with its disks and network settings. However, your Vagrant file remains untouched, ready for when you need it again. So if you are sure you want to destroy your virtual machine, type Y and press enter. And that's it. You have successfully learned how to start, stop, and remove a Vagrant environment. And by that, we get to the end of our lesson. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson on how to run the project labs using Vagrant. Let's start our lesson by cloning the course project. To clone the course project, I will type git clone, then the URL to our Git repository. Now let's press enter. Once you clone the repo, you can start provisioning labs from each project's Vagrant file. As you can see, the repo has Vagrant files for 5 projects. In each project, you will find the Vagrant file. For some projects, you will find multiple Vagrant files or bash scripts. It depends on each project, and you will find your way when you watch and follow each project lessons. In case you have any questions, please don't hesitate to ask. When you work on any project, change the directory to the project name. For example, let's change the directory to project 1. So let's type cd, or first let's go to our cloned repo, which is Linux mastery-real world job simulation projects. Now let's change directory to project 1 and let's execute ls-l. As you see, this project only has a vagrant file. Let's cat this file. So I will execute cat vagrant file. And also, if you are using Visual Studio, you can select the vagrant file from project 1. And that will be much easier to explain. From this file, we can see that this virtual machine will provision a Rocky 9 Linux virtual machine with 1 GB RAM and 2 CPUs. The VM will be provisioned with IP 192.168.56.100. In the vagrant file, we use the shell to configure a 4 GB swap file. Okay, now let's provision the virtual machine using vagrant commands. So I am here inside project 1. So here I am inside project 1 directory and I have my vagrant file. So let's execute vagrant, then the up option. Now press enter. This process may take 2 to 5 minutes or more, depending on the instructions inside the vagrant file. I will pause the video until vagrant finishes its work, then I will come back. I am back and vagrant has finished its job. To connect to the virtual machine via SSH, you have two ways to do so. If you only have one machine created from the vagrant file, then you can just type vagrant then SSH. If you have more than one virtual machine created from the vagrant file, you should specify the virtual machine name. You can identify the machine name from the vagrant file from the config virtual machine defined. As you can see here, the name of this virtual machine is lab1. So to connect to lab1 terminal, just type vagrant.exe, or in case you are on Linux, it will be only vagrant, then the name of the virtual machine, which is lab1. Now press enter. As you see, we are now logged into lab1 via SSH and we can start following our video lessons for project 1. At any time you want to exit the shell, type exit. Once you finish working on any lab, don't forget to do vagrant destroy. Vagrant will request a confirmation. So if you are sure that you want to terminate the lab1 virtual machine, type Y and press enter. And as you can see, the virtual machine has been destroyed or terminated. And by destroying the project 1 lab, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to the System Health and Performance Monitoring project. Our agenda for this presentation is to cover the importance of monitoring, key metrics to monitor, traditional monitoring tools, automated monitoring with cron jobs, alerting for critical events, and performance reporting. Let's begin by understanding the importance of monitoring. Monitoring is the process of collecting and analyzing data about the health and performance of your system. It is essential for preventing problems, identifying bottlenecks, and ensuring that your system is performing at its best. Poor system performance can have negative consequences, including decreased productivity, reduced reliability, and increased security risks. Proactive monitoring can help to identify and resolve problems before they cause significant disruptions. Imagine that you have a server which you don't know anything that's going inside. It will be impossible to know about a problem before it happens, and that may lead to a slowdown in the server or a potential shutdown that may affect business continuity. Monitoring systems will make you aware of a problem before it becomes a bigger issue. By monitoring your system, you can detect, for example, CPU and memory usage spikes. Once you see those spikes or get notification about them, you will be able to take action to solve the problem before it affects business continuity. Now let's talk about the key metrics essential for monitoring the health and performance of your system. These metrics provide insights into various aspects of system performance and are crucial for identifying potential issues. CPU utilization. This metric measures the percentage of time that the CPU is busy processing tasks. High CPU utilization can indicate a bottleneck in the system. Memory usage. This metric measures the amount of memory that is currently in use. High memory usage can also indicate a bottleneck. Disk input-output. This metric measures the amount of data being read from and written to the disk. High disk input-output can suggest a bottleneck or a potential disk failure. Network traffic. This metric measures the amount of data being transmitted over the network. High network traffic can indicate network bottlenecks or problems. Application performance metrics. These include metrics specific to the applications running on your system, such as response times and throughput. Understanding and monitoring these key metrics will help in maintaining optimal system performance and identifying areas that may need attention or optimization. Let's discuss traditional monitoring tools essential for system health and performance monitoring. Tools like HTOP provide a real-time overview of the system's resource usage. VMstat offers detailed statistics about memory and CPU usage. IOstat is crucial for statistics about disk and network input-output. And SAR collects historical data about system performance. Additionally, there are specialized monitoring tools for specific purposes like database and network monitoring. Understanding these tools helps in effective system monitoring and analysis. Knowing that traditional monitoring tools is a skill for any Linux system administrator, you may find yourself in a situation where you need to troubleshoot a live server from its terminal. It is important also to automate monitoring a system using traditional monitoring tools. It doesn't make any sense to be inside a Linux terminal for 24 hours to monitor the system. You may ask now why you should use traditional monitoring tools if you can use modern tools such as Prometheus and the Elastic Stack. I am glad you asked this question. It's advisable to use modern tools to monitor your systems, especially since modern tools can centralize your monitoring by collecting metrics from all your systems to a single location where you can monitor multiple systems and applications. But as we mentioned moments ago, traditional tools are a skill, and there are situations where you won't find anything except the traditional tools to save your life. Also, the purpose of this project and the future projects in this course is that we think and learn together from experience to build up our skills and gain experience with different tools and techniques. I think I have answered your question, so let's go back to automation. Automation will save your time, and we will see that together in this project's lessons. Let's talk about alerting. Quick action is key in preventing problems from escalating. Alerts can be set for high CPU utilization, low memory usage, and high disk input-output. Various alerting mechanisms, such as email, SMS, or push notifications, can be employed to notify relevant personnel promptly, ensuring swift responses to critical system events. Let's cover the role of performance reporting in system monitoring. Regular performance reports are invaluable for tracking trends, identifying anomalies, and making informed decisions to optimize the system. Tools like the SAR tool and commercial reporting tools can be utilized to generate detailed performance reports. facilitating a deeper understanding and analysis of system performance over time. To conclude, system health and performance monitoring is an essential part of maintaining a healthy and productive IT environment. By implementing a comprehensive monitoring strategy, you can proactively identify and resolve problems, optimize system performance, and ensure that your system meets your business needs. I encourage you to assess your current monitoring practices and make the necessary improvements to ensure effective monitoring. And by that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on our tasks for the System Health and Performance project. We have 3 tasks that we will work on in this project. Let's start with the first task, set up regular system resource monitoring. In this task, we want to set up the necessary tools on servers for regular system resource monitoring. During work on this task, we will learn about tools such as HTOP, VMstat, and IOstat. Now to the second task, implement a script to alert for high disk usage. This task is about developing a script that monitors disk usage on our servers to notify us when the disk usage reaches a critical level. Let's move to our third task, schedule monthly performance reporting. This task is about using a tool such as SAR to automate the monthly performance reporting. Now we have seen an overview of each task. Let's put them in progress. And by that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will start our journey with the System Health and Performance Monitoring project. We will begin by updating the system on Rocky Linux virtual machine. So let's type sudo yum update. Next, we will install HTOP and sysstat. So let's type sudo yum install HTOP sysstat. As you can see, I already installed the HTOP and sysstat on this system. In this lesson, we will focus on HTOP. In future lessons, we will discuss sysstat. But for now, let's execute HTOP. HTOP provides insights about your system. From the HTOP output, you can see that this system has 2 CPUs, and it also shows the CPU utilization of each CPU. HTOP displays information about the memory and the swap, showing the total memory and swap and their usage. You can also see the load average and the system uptime. There are 2 tabs in the HTOP interface, the main tab and the input-output tab. The main tab provides information about running process on the system, showing process ID, the user running the process, virtual memory, and reserved memory, CPU and memory utilization for each running process that shows the percentage the process is consuming from the CPU and memory. Under command, you can see the running command or process. You can also manage HTOP through function keys. For example, you can quit HTOP by pressing F10, terminate or kill a process with F9, and sort the output by F6. Let's press F6 to sort the output. As you can see, we can sort by process ID, user, CPU, and memory percentage. Let's sort by memory utilization, so I will select %_mem. Now press enter, and as you can see, HTOP now sorts the output by memory percentage. Now let's simulate a memory leak using simple Python script I have developed for testing purposes. Don't execute the script in a production environment. Test it in a playground environment to learn. Let's go to another tab, and let's execute ls. Here is the Python file I will execute, mem_leak.py. Let's view the file's content. So let's type cat mem_leak.py. This Python code will consume 1 megabyte of memory with every execution of the script. The script will run indefinitely because it has a while true condition and waits 1 second between each execution. To execute the script, type python 3 mem_leak.py. Now let's return to the htop command. Since we are simulating a memory leak, ensure that the output is sorted by memory percentage, which we already did. As you can see, our script is now displayed under command. And from the user, you can identify the user running the script or process, which is, in our use case, user Vagrant running the process Python 3 mem_leak.py. You can also see the memory percentage is increasing and that memory usage increases every second by 1 megabyte. Now, if you are on a system running htop and notice a process consuming memory, what should you do? First, ask yourself if this is a normal process. If it is, investigate why it consumes memory. Does this process or service need optimization to consume less memory? Optimization is not always the solution, as it may lead to poor performance. However, this is something you will learn through trial and error. If the service such as a database service or web server can be optimized, do so. If it affects performance, you may need to increase the memory for your virtual machine or physical server to solve the problem. What if the process consuming memory is a one-time process, such as one running for a specific job for a period, and it causes a memory leak? In this case, see if the process can be optimized or not. You may find yourself terminating the process and stopping it until you fix the problem. Otherwise, the process may be malicious. In that case, terminate it immediately and investigate how it was executed on your system to prevent recurrence. Now let's execute multiple processes from multiple leaks to simulate how dangerous a process consuming memory can be. Go to the tab where the memleak script is running and press Ctrl C to terminate the process. Now let's execute ls. And I have a shell script here named run_mem_leak.sh. Let's view the content of this script. So let's type cat run_mem_leak.sh. As you see, this bash script has a for loop from 1 to 20 and executes memleak in the background, running memleak 20 times in parallel. Let's edit the bash script to run the script 100 times. So let's type vi, then run_mem_leak.sh, and I will change the for loop to be 100. Then I will save the file. And by the way, this is very dangerous and will cause the lab 1 virtual machine to become unresponsive. So don't test this script on a live system. Just test it in a playground virtual machine where you don't care about the consequences. So now let's execute the script. So I will type bash, then run_mem_leak.sh. Let's go back to the htop tab. You can see the process mem_leak everywhere with a spike in memory usage and the system starting to consume swap. There is also a spike in CPU usage. If you troubleshoot a system and find a process consuming both memory and swap, something is definitely wrong with that process. The system will terminate this process automatically to protect itself. But if the process restarts or recreates itself automatically, the system will eventually crash. As you can see now, the system is unresponsive because the process consumed all the memory and swap. Now I will try to execute the pkill command in the other tab to kill the process. If it doesn't work, I will have to reboot the virtual machine. So let's type here pkill, then Python 3, and as you notice, it takes some time to type because the system is not responsive. Now let's press enter, and I also pressed enter and the system is not responsive, or it's very slow. So I will wait for maybe 1 minute to see if it will respond back or not. So it took like 30 seconds to finish the command or to execute the command. Now let's go back to tab 1. It seems the pkill command terminated all Python 3 processes and the system is back to normal. Now let's see how we can terminate a process from htop. So let's go back to the second tab and let's execute mem_leak.py. The process is now running. As we can see here, we can see the process under the command. To terminate the process, select it, then press F9 and select the signal. I will select sig term. Now press enter to send the signal to the process. As you can see, the process is no longer shown. Let's check the second tab. As evident from the output, the process has been terminated. Returning to the htop tab, to exit htop, let's press F10. If you suspect that a system has or had an issue with memory, you can detect that from the logs. To detect memory issues on a system, execute sudo cat/var/log/messages, then pipe that to grep memory. If you see out of memory in the output, know that a process is consuming memory and the system terminated it to protect itself. The output shows which process caused the out of memory issue and has been terminated. When you see a process causing out of memory, investigate the process to determine your options. Is it a process that can be optimized, a process that needs to be terminated and ensured it won't run again, or a normal process that can't be optimized and needs more resources? In this case, you may need to increase the system memory. And with that, we come to the end of our lesson. Thank you for watching and see you in next lesson. So, in our previous lesson, we learned together about htop and simulated a memory leak on a Linux virtual machine. In this lesson, we will continue learning about htop, focusing on the input-output tab. So, after executing the htop command, you will be by default in the main interface or the main tab. To go to the input-output, just select the input-output tab. In the input-output tab, you can see the process ID, the user running the process, disk read-write, disk read-only, and disk write-only, as well as the command being run. Now it's time for some fun, simulating read and write to the disk. Let's go to another tab and let's execute ls. I have two files here, read_spike.sh and write_spike.sh. Let's view the write_spike.sh. So I will execute cat, then write_spike.sh and press enter. This script will create a big file under the temp directory. This command will create a 10 GB file size. We also have a while true condition which will execute the script indefinitely, waiting 1 second after the execution of the dd command to execute it again. Now let's view read spike.sh. This script will read the file we created from write_spike.sh. It also has a while true condition to execute the command indefinitely, with a 1-second interval between each execution. Let's start with the execution of write_spike.sh. So let's execute bash, then write_spike.sh. Let's go back to the htop tab, and from the output I see the command we executed, and it shows the disk write, which is like 800 or 700 megabyte per second. The writing process is not only writing to the disk. As you see from the CPU and memory, there is a spike in both. If you are working on a system and find that there is a process writing to the system that causes CPU and memory spikes, you need to investigate this process because it may cause performance issues, slowing down the system and causing other applications running on the system to slow down. Now let's terminate the process. So I will go to the other tab which we executed the script from, and I will just press Ctrl C. Now let's simulate a read process. So I will execute bash read_spike.sh. Let's return to the htop command, and this time we see disk read, which as you can see it's 1 gigabyte or 2 gigabyte per second. Sometimes it's 700 kilobyte per second. You will also notice a spike in memory and CPU usage. Let's go to the main tab and let's sort the output by CPU. So to sort the output, I will press F6. Then I will select %_CPU. As you see, the read process we executed consumes a percentage of the CPU and the number is increasing. If you find a process like that, you need to investigate and take action, as this can cause system slowness as mentioned before. Now let's go to the second tab and let's press Ctrl C to terminate the script. And also let's delete the file the script created. So I will do rm/temp then big file. I believe you now see the importance of the top tool in troubleshooting and monitoring. And with that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on VMstat, which is a tool included in the sysstat package that we installed in our previous lessons. VMstat provides information on memory, swap, input-output system, and CPU. Let's execute VMstat. And from the output, as you can see, I can know information about the memory, the swap, the input-output, the system, and the CPU. To know what options you can add to the VMstat command, let's execute VMstat with --help. And from the output, you can know that -a is used to get the active inactive memory, -f is used to get the number of forks since boot, and so on. Now let's execute VMstat command again. From the output, as you can see, the values for swap, free, and cache are all in bytes. To make VMstat show these values in megabytes, let's execute VMstat with -s, then m. For me, it's much easier to read values in megabytes or gigabytes for a quicker understanding of the situation. And as you see from the output, now all the values in megabytes. Now let's execute VMstat -s m, but this time I will add 1 and 5. Now press enter. As you can see from the output, VMstat shows 5 outputs with a 1-second interval between each. This can help you identify a memory leak issue. For example, from the 5 outputs here, it seems the values are normal with no spikes. For instance, the free memory remains the same, which indicates no problems so far. You can modify the command to show 10 outputs with a 5-second interval. So I will change this to 5-second intervals, and I want the VMstat to print 10 outputs. As you can see, it takes 5 seconds for a new output to show up, and from the output you can see that the free memory and used swap are the same, which indicates no problem on this system. Now let's simulate a memory leak. Let's go to another tab. Recall from our previous lesson that we executed the mem_leak.py script to consume 1 megabyte of memory every second. And we will also execute the run_mem_leak.sh. Let's run it again, but first let's modify the for loop inside it to be 20. So I will open or edit the run_mem_leak.sh, and I will change the 100 here to be 20, and let's save the file. Now let's execute the script. So bash run_mem_leak.sh. Let's go back to the other terminal and let's execute vmstat-s m1 for intervals and 20 output. As you can see from the output, the free memory is decreasing significantly, which indicates an issue on the system caused by a process. Now you need to troubleshoot this problem to detect the process causing this issue. And of course, you can use the htop command to investigate more. Now let's execute vmstat-sm. As you see, the free memory is 54 megabyte. Now let's see how we can get the free memory value using the awk command. When we get this value, we can develop a shell script to send us a notification in case the free memory value is less than a specific value. And this script will be an assignment to you in future lessons in this project. But for now, let us see how we can get the free memory value using the vmstat and the awk command. The first part of this command will show the output we saw a moment ago, which shows the free memory value. The pipe here will take the output from the first part and send it to the awk command to process it. The awk command will go to the third line in the output and print column number 4 from it. Now let's press enter, and as expected, the free memory value is printed out from the command. So let's explain the vmstat-sm for more clarification on how the awk processed this command. So here from the output we have 3 lines, 1, 2, 3, and the free value in the 4th column. So this is the first column, second column, third column, and 4th column. So the awk command will go to the line 3, then print column number 4, which is the value of free memory. And it seems that our Python script is still working in the background because like the memory value is decreasing. Don't forget to terminate the Python 3 command using the equal Python 3. As I mentioned, in the future lesson, I will give you an assignment to develop a bash script to notify about the free memory using the vmstat command with the aw command we just saw in this lesson. For now, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on the IOStat tool, which is part of the sysstat package that we installed in our previous lessons. Let's start the lesson by running IOStat. IOStat shows information about the Linux kernel, today's date, the system architecture, the number of CPUs, and the average CPU usage. IOStat also displays the device attached to the system, transactions per second, which is how many read and write operations per second, the amount of read per second, the amount of write per second. It also shows the total read and writes that have occurred on the system since it was booted. As usual, I prefer to deal with numbers in megabytes or gigabytes, so let's execute iostat --human. Now let's press enter. As you can see, the numbers are now in megabyte or gigabyte. Now let's simulate read and write spikes using our scripts from the HTOP lesson. So let's go to the other terminal and let's start with the write spike. So I will execute bash, then write _ spike.sh. Now let's go back to our terminal here and let's execute iostat --human. From the output, I can see that there is a write operation of 2.3 megabytes per second. Now, let's check the available devices attached or mounted to the system by executing df-h. From the output, I can see that /dev mapper rocky root mounted to the root partition file system. So I want iostat to give me information about this device. To do so, I will execute iostat -p, then the device, then --human. And that will provide some statistics for the root partition only. Now press enter. As you can see, the write permission has increased to 3.1 megabytes per second. Let's go back to the other tab and let's press Ctrl C to terminate the bash script. Now let's simulate the read spike using bash read spike.sh, and let's go back to the terminal where we executing the iostat command, and let's execute the iostat -p /dev/mapper/rocky -root --human command. And as you can see from the output, the read is 1.1 megabytes. Let's execute the command again. And as you can see, the read operation increased to be 1.3 megabyte. Now, how can iostat help me? Using iostat can help you identify a storage problem because reading and writing to the system can affect performance. By using iostat, you can identify such a problem and start to investigate more to fix the issue. Now let's go to the other tab and let's press Ctrl C to terminate the running process. Also, let's delete the file from temp directory. The file name is big file. And with that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will learn about the SAR tool, which is also part of the systat package that we installed in our previous lessons. SAR generates reports on CPU, memory utilization, input, output, and other system statistics. To start, let's execute SAR. Let's scroll up. From the output, you can see that SAR shows the kernel version, the host name, the date, the system architecture, and the number of CPUs. From the SAR report, as you may notice, the idle percentage drops down, and at the same time, the system percentage or the CPU utilization shows a spike. When you see something like this, it indicates that there was a problem on the system at 7 a.m. or to be specific, 7:30 a.m. When you see something happened like that, you need to investigate what happened at that time. Let's check what other options we can use with SAR. To do so, I will execute SAR --help. And from the output, you can see that with -b capital, you will get paging statistics, and -b small, you will get input, output, and transfer rate statistics, and so on. If you want SAR to generate reports on all metrics it collects, you can execute SAR -a capital. SAR will generate a report about CPU, memory, storage, and all metrics it collects. Now let's check where the SAR log files or generated reports are stored. So let's execute ls var log then sa. So SAR keep its logs or reports under /var/log/sa. You will always find the file starting with SA followed by the day of the month. Let's execute the same command again and add the -l option to it. And as you can see, SA12 is for 12th of January, SA18 is for 18th of December. If you want to view a specific report by its date, you can execute SAR -f then the path to the file. So I will add /var/log/sa and let's select SA12 to show the report for the 12th of January. Now press enter, and as you can see, it will print out the generated report for 12th of January. When working with SAR, it's advisable to generate reports for the metrics you are interested in. For example, SAR -r will show memory metrics. And it seems that I didn't provide the correct command, so I just added SAR minus. So let's execute the command again, but this time with the R to get metrics about the memory. Now press enter. And as you can see from the output, you can get the memory free, the memory available, the memory used, and the memory utilization percentage. Now, if you want to generate a report on CPU, you can execute SAR -u. And from the output, you can see that you will get statistics or metrics about the user percentage, noise percentage, system percentage, and input-output weight percentage, and so on. To generate a report on input-output, execute SAR -b small. And from the output, you can see that you get metrics about transaction per second, read transaction per second, write transaction per second, and so on. You can also add multiple options like SAR -RUB, which will generate a report about memory, CPU, and input-output metrics. SAR can help you detect and identify issues that occurred on the system so you can check logs and investigate what happened to fix any problem you see. By that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson where we will develop a bash script to notify us about high disk usage on Linux servers. This script will check disk usage regularly, and if the disk usage exceeds a defined threshold, it will send a notification to a Slack channel. I am using Visual Studio Code for development, so I will write the script here and then copy it to the Lab 1 virtual machine. Let's start by adding the shebang to tell the script that bash will be used to execute it. Since I will integrate the script with Slack via a Slack webhook URL, let's define that next. So I will add comment here, Slack webhook URL, and it's a good to comment your code for clarity. Now let's define the Slack webhook URL variable. So it will be Slack _webhook _URL equal, then I will add the value later. Now let's configure our threshold. So I will add also a comment here, the threshold for disk usage, which will be 90%. Now to the variable threshold equal 90. Now let's get the current disk usage percentage. So I will add a comment here, get the current disk usage percentage. And I will define a variable here with the name disk _usage equal. Now let's check how we can get the current disk usage percentage. So from the terminal on Lab 1, to get information about the available or the attached partitions to the system with their disk usage, you can execute df-h. Let's focus on the root partition, which is critical. If it fills up, the system won't work properly until space is freed. So I am interested in the usage percentage of the root partition, which is in this case 6%. So let's see how we can get this value. So let's execute the same command, but this time provide the mounted point to the root partition, which is /. As you can see from the output, I will get only information about the root partition. So from this output, I can know that the size is 125 gigabytes, the used 7 gigabyte, the available 118 gigabytes, and the usage is 6%. Now I want only to get or to print the line 2 here. So to do that, I will execute the same command, df-h / then pipe to awk command. Then I want to print out line 2 only, so I will do nr = 2. Then from line 2, I want to get the usage percentage. So the usage percentage is in column 5. So we have 1, 2, 3, 4, 5. So I want to print column 5 only. So I will do curly braces, then print $5. Now let's press enter. And as you can see from the output, it shows the value of the usage percentage, which is 6%. Okay, now I don't want the percentage sign here, so I only want the value 6. Let's check how we can do that. So I will execute the same command again. Then I will pipe that to cut -d, then percentage to remove the percentage sign. And also I will provide -f1 because I am interested in the field before the percentage sign. Now let's press enter. And as you can see now, I'm getting the 6 value, which is the value I need. Now let's copy the whole command here and let's go back to our script, and I will type here $, then 2 braces and the command between them. So the disk usage will be the value from this command. Now let's get the server hostname to send it with the alert. So again, a comment server hostname, and I will define a variable server underscore hostname equal, then the command hostname. For testing purposes, let's modify the threshold to a lower value like 5%. So here I will change this from 90 to 5. Now let's add our main logic for this script. So here I defined an if statement. So this if statement will check the disk usage, and if it's greater than the threshold we have configured, then it will define a message value with exclamation mark, and the disk usage on server hostname is at disk usage percentage. Then after that, it will send the alert message to Slack using the curl command. Now let's copy the script to the lab1 virtual machine. So let's first create a directory scripts. Sorry, I need to add sudo. So sudo makdir /scripts. Then I will change the owner and the group for the scripts directory to be Vagrant. So sudo chown -r vagrant dot then scripts. Now let's create the script itself. So it will be under scripts /disk_monitor.sh. Now press enter, and it seems that I don't have nano here, so I will install it using yum install nano. Now we have nano. Let's edit the file and let's copy the script from here to the virtual machine, and also let's change, or let's configure the Slack _webhook_URL. So I will paste the webhook URL here, and don't try to copy this Slack webhook URL because it will be useless after I finish recording the lessons. So now let's save the file and let's make it executable using chmod +x/scripts/diskmonitor.sh. Now let's execute the script. So let's type scripts, then disk_monitor.sh, and I didn't get any error message, so it's a good sign. Now let's open the Slack in our browser, and as you can see in the Ops Alerts channel, I'm getting an alert about the disk usage on lab 1 is at 6%. Now let us see how to add the script to a cron job to execute it regularly. Before adding the script to cron tab, let's revert the threshold to 90%. So I will edit the script here on the virtual machine, nano/scripts/diskmonitor.sh, and the threshold I will revert it to be 90%. To edit the cron tab, type cron tab -e and I to insert. Now let's add the following to run the script every 15 minutes. So I configure the cron job to run the script every 15 minutes, and also I am redirecting the input/output from the disk_monitor.sh to dev_null. Now let's save the file, and after saving the cron tab, let's restart the cron service using or by executing the sudo systemctl restart cron-d. With this setup, our script will regularly monitor disk usage and send alerts to Slack if the usage exceeds the threshold. And that brings us to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will develop a script that uses the SAR command to generate a monthly report for the system. Let's start developing our script, and the first line is the shebang. Next, let's define a variable for the report directory. So I want the report directory to be /var/log/SAR_reports. In this path, I will save the reports I am generating from this script. We will append the date to the report file name. So let's define a date variable. So let's copy it, and from the lab1 terminal I will paste the command and press enter, and as you can see, this command will generate the current date in the format year, month, day. Now let's define the report file variable. So the report file will be created under the report directory. Then the name of the report will be CPU_mem_IO_reports_, then the date coming from the date variable. Now let's ensure that the script creates the report directory. So I will execute the command sudo make_dir -p, then the report dir value. Finally, let's provide the command to generate the report. So our command will be sudo sh-c, then the command sar -u rbd to generate the report for the CPU memory input/output report. Then the output from the sar command will be redirected to the report file value. Now let's copy the script to the lab1 virtual machine. So I will save it in /scripts SAR_reports.sh. Let's save the file and let's make the file executable by executing chmod +x, then the path to the bash file. After running the script, you can check the reports directory by executing ls/var/log/SAR_reports. And as you can see, the script generated our first report with the name CPU_mem_IO_report, then the current date. At any time you want to view this report, you can type cat var log SAR_reports, then the file you want to view its report. And from the output, you can see that You can now check the report for the current date, and also you can investigate to see if there was any problem at a specific time. Now let's schedule the script to run using a cron job. So I will type cron tab -e, and I will press I and enter to get to a new line. And let's add the following line to execute the script at midnight on the first day of each month. So this cron job will be executed at midnight at first day of each month. Also, let's redirect the input-output error from this to dev null. Now let's save the cron tab and let's restart the cron service using sudo systemctl restart cron d. By restarting the cron service, we have set up a monthly system report generating using the SAR command. And that brings us to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. This is your assignment for this project. Do you recall this command? This command prints the value of free memory. I want you to develop a bash script that notifies you in case the free memory is less than 100 megabytes. Enjoy and happy learning. Hello and welcome back to our final lesson on the System Health and Performance project. In this lesson, we are concluding our journey where we have successfully accomplished 3 key tasks. Let's quickly recap. We started by setting up essential monitoring tools on our servers. Utilizing tools like HTOP, VMstat, and IOStat, we have now a robust system in place for ongoing resource monitoring. This setup ensures that we are constantly aware of our system's health and performance. Our second task involved developing a script to monitor disk usage. This script is now actively monitoring our servers, ready to notify us whenever disk usage approaches a critical threshold. This proactive measure helps us in preventing potential system overloads or failure due to high disk usage. Lastly, we automated our monthly performance reporting using tools like SAR. This automation has streamlined the process, making it efficient and consistent. We now receive regular, detailed reports, giving us insights into our system's performance over time. With these tasks completed, we have greatly enhanced our system's health and performance monitoring capabilities. This proactive approach will aid in maintaining optimal system performance, reducing downtime, and ensuring a smoother operational flow. And by that, we get to the end of this lesson. See you in our next series of lessons where we will delve into new challenges and continue our learning journey. Until then, keep exploring and enhancing your skills. Greeting fellow sysadmins. In this lesson, we are delving into 2 crucial tools for fortifying your Linux network defenses: SSH access log auditing and the versatile VPN. Buckle up and prepare to unlock the technical intricacies and practical applications of these security powerhouses. Imagine SSH as a gateway to your system, but instead of physical logs, it leaves digital footprints in the form of access logs. These detailed records capture every login attempt, timestamp, username, IP address, and even executed commands. Analyzing these logs acts as a virtual security guard, providing real-time insights into suspicious activity and potential intrusions. But the benefits of SSH log auditing extend far beyond mere intrusion detection. They empower you to identify suspicious login attempts and thwart them before they escalate, gain granular insights into user behavior, and ensure adherence to security policies, meet stringent regulatory requirements like PCI DSS and HIPAA with ease. Leverage detailed logs to reconstruct events and identify the root cause of security incidents. Now envision a secure tunnel safeguarding your data traversing the vast internet. That's the essence of a VPN. It utilizes robust encryption algorithms to scramble your data traffic, rendering it unreadable to any potential eavesdroppers. Think of it as an impenetrable cloak, shielding your sensitive information during online transmissions. And the use cases for VPNs are as diverse as your network itself. Empower your workforce to access corporate resources seamlessly from any location, ensuring data confidentially even on untrusted networks. Implement granular access controls within your network, restricting specific resources to authorized users only. Break free from geographical limitations and access global resources without boundaries. Encrypt your data traffic whenever connected to public Wi-Fi networks, shielding it from potential snooping and man-in-the-middle attacks. Remember, securing your network requires a multi-layered approach. Just like a robust firewall and intrusion detection system, both SSH log auditing and VPNs play critical roles. Together, they gain comprehensive insights into network activity and user behavior, safeguard sensitive information from unauthorized access and data breaches, facilitate secure and compliant remote work environments, break free from geographical limitations, and access essential resources. So, take charge of your network security today. Integrate SSH log auditing and leverage the power of VPNs to build an impenetrable fortress against cyber threats. Remember, a secure network is a foundation for success, and with these tools at your disposal, you can achieve just that. Thank you for watching, and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will take a close look at the two tasks we have for the network config and security project. We have two tasks on our to-do list. The first one is about configuring and testing a VPN for secure remote access, and the second task is for the regular audit of SSH. Let's open our first task. This task involves configuring a VPN solution for the company. To complete this task, you need to choose a suitable VPN solution, install and configure the VPN server, set up user authentication and access controls, then test the VPN to validate the work. Now let's check the regular audit of SSH access logs task. What is needed in this task is to regularly audit SSH logs to identify and respond to unusual activities that may pose a threat or lead to a security breach. Working on this task will be valuable for our troubleshooting skills, as we will deal with some logs and SSH configuration. Let's move the tasks to in progress. I am very excited to work on these tasks, and I am sure you will enjoy working on them as well. See you in the next lesson. Hello and welcome to a new lesson on the regular audit of SSH access log task. In this task, we will explore SSH logs for auditing purposes and learn how to secure SSH based on our findings in the logs. Let's begin our lesson by explaining the Vagrant file we will use to launch a Rocky Linux 9 virtual machine for practice. This Vagrant file will provision a Rocky Linux 9 virtual machine. The most important part here is the shell commands Vagrant executes on the virtual machine. These commands change the root password to root password ! and add a new user named test to the system with the password ! Additionally, I will enable root user access for SSH and enable password authentication. To provision our virtual machine for this lesson using Vagrant, execute the Vagrant up command. Let's execute the command Vagrant up. It may take a few minutes to finish provisioning the virtual machine, so I will pause the video and return once it's done. I'm back, and as you can see, Vagrant has finished provisioning the virtual machine. To access the virtual machine's SSH, let's type Vagrant SSH. Now I am connected to the Lab2 virtual machine via SSH. Let's change the font colors by pasting the following command and press enter. Remember, I configured SSH on this virtual machine to allow root access, and I have changed the root password to root password ! Let's test a failed login from the user root. Now let me open another terminal and let's type SSH -p2224, then the user root at then my Windows machine IP, which is 192.168.0.223. Now let's press enter and let's type yes. I will provide a wrong password for the user root multiple times, resulting in a permission denied error message. Now, let me try to connect with the correct password. So, I will execute the command ssh -p2224 root at 192.168.0.223. So, I will execute the same command again. Now press enter. And this time I will provide the correct password. As you can see, I managed to connect to SSH with the correct password. A notification indicates that the last failed login was from the 10.0.2.2 IP with 3 failed login attempts. Such information might indicate a brute force attack attempt. When you see a number of failed logins, you should investigate, which we will do in this lesson. In the Red Hat family, SSH related logs are located in var log secure. Let's read this file by executing sudo cat. If you scroll up, you will find information about any failed SSH login attempts. The logs also indicate that the password for the root user was accepted from the 10.0.2.2 IP, which previously had failed attempts. This could be a normal failure from a user who misspelled their password, or it could indicate that someone managed to guess the root password. In such a situation, you should investigate further, change the root password immediately, and block the IP if it is found to be malicious. Moving on, let's use the last log command to display the last login information for all users on the system. So let's execute last log. Now press enter. As you see from the shown output, you can see information about the username of the user account, the terminal or interface through which the user logged in, the host name or IP address from which the user logged in, and the date and time of the last login. The last log command helps in auditing SSH access, providing information about all users, their login times, and login IPs. If you find system or service users like mail or SSHD logged into SSH, it indicates a compromised system, as these users should have no SSH login capabilities. Let's execute two commands to illustrate my point. The first command is cat/etc password, then grep sshd. And the second command is the same command, but this time we will grep test user. For the SSHD user, it's configured by default with the /sbin/no login shell, which prevents user login, a common security measure for system accounts. For the user test, we can see that it has shell access. If a system user has managed to log into SSH, it's a serious issue. When we read the secure log file, we find a lot of information that might not be relevant to our audit. Let's execute some commands to filter the result. Our first command is sudo grep -i failed /var/log/secure. This command searches for any failed log entries. As you see from the output, failed password for root from 10.0.2.2 for the SSH. Our second command is sudo grep ssh /var/log/secure, which filters messages containing the word SSH. As you see from the output, I will get all entries with the SSH word, and from it I can see that there is a failed password for root from 10.0.2.2 IP and also accepted password for root from 10.0.2.2. Now let's type sudo grep -i failed password /var/log/secure, which focuses on failed password entries. And as you can see, from the shown output, I only got the failed password entries from the secure log. Now let's execute the sudo awk $6 /sshd/ between single quotations, then /var/log/secure. This command will display all lines from the /var/log/secure file where the 6th field contains the string SSHD. This is typically used to filter log entries related to the secure shell daemon, such as attempts to connect to the SSH server, both successful and unsuccessful. This can be important for security auditing, checking for unauthorized access attempts, and general SSH server monitoring. Now let's press enter. And as you can see, I have authentication failure here for user root from the remote host 10.0.2.2. For more specific information like failed password login attempts, IPs, and dates, let's execute sudo grep failed password /var/log/secure. Then I will use the awk command to print fields number 1, 2, 3, 6, and 11. Let's press enter. And as you can see, I got the information I need, which are the IP and dates. So this command filters the secure log for failed password attempts and displays relevant details such as the IP and the date. This concludes our lesson. I hope you now understand the importance of auditing SSH logs for security. In the next lesson, we will learn how to secure our SSH configurations based on our findings. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. We are continuing our work on the regular audit of SSH access logs task. If you recall, one of our subtasks is to update security measures based on what we found in the previous lesson, and that's what we are going to focus on today. Let's recall what we discovered in our previous lessons. So I will execute sudo cat /var/log/secure. Then I will search for the word failed inside the secure log using the grep -i command. From this output, we observed some failed attempts to log into SSH using the root user. Following best practices, we should prevent the root user from accessing SSH and disable password authentication for all users. Instead of using a username and a password for remote SSH access, we should adopt the use of public-private keys. Additionally, the system should be accessed by a user other than root, who should have sudo permissions like the user Rocky in our case study. Disabling password authentication will prevent brute force attacks, or in other words, render them ineffective. Now, let's explore how to prevent the root user from accessing SSH remotely, how to disable password authentication, and how to use public-private keys instead. So, let's edit the SSHD configuration file by typing sudo nano /etc ssh then sshd_config. And this is the main configuration file for SSH service on Red Hat family. Let's press enter and let's click Ctrl W to search inside the file, and I will search for permit root login, and I will uncomment this one and I will change it to be no. So by setting permit root login to no, this will prevent the root user from accessing SSH remotely. Let's save the file and let's restart the SSHD service to apply the changes. So I will type systemctl restart SSHD. I didn't get any error message, so this is a good sign that SSH service restarted successfully. To verify that, I will execute the same command, but this time I will type status. And as you can see from the result, the SSHD service is active and it's running since 23 seconds ago. Now to verify our new settings, I will connect from another terminal to this system. So let me bring the terminal here. So let's type ssh-p2224, then the root user at the IP of my Windows machine. Now let's press enter and I will copy the password from the Vagrant file, because if you still remember, Vagrant file changed the password for root to root password ! So I will copy this one and I will paste it here and press enter. After providing the root password, you will notice that I can't log in as the root user because we prevented user root from accessing the system remotely. Now let's test with the user test. So I will execute the same command, but instead of root, I will type test and I will copy the password of user test from the Vagrant file. Let's press enter and let's provide the password here. As you can see, the user test managed to access SSH remotely, while the root user didn't, because we set permit root login to no, disabling SSH access for the root user. Let me exit the system. Now let's disable password authentication. But first, we will generate a public private key for the user Rocky. And also, we don't have user Rocky on the system, so let's create the user together. To create a user, I will type sudo user add, then Rocky. Now press enter. Let's set a password for user Rocky. So I will type sudo password Rocky, then press enter. I will provide my password, then I will retype the password again. Now we have set a password for user Rocky. Now let's create a public private key. So from my local machine, I will type ssh-key-gen to generate a public private key, and I will define the path to this public and private key to be in /home/turkey/.ssh/lab2. The ssh-keygen asks me to enter a passphrase. As a best practice, or to follow the best practice, you should provide a passphrase here to be as your password when you will access any system using your private public key. But for this lesson, I will not provide any passphrase. So I will just type enter and I will type enter again. It seems that I didn't provide the correct path to the command because I added here a bracket to the path. So let's execute the command again, but this time I will ensure that I will copy the path only. So the key will be saved to /home/turkey/.ssh/lab2. Let's press enter and press enter again. And as you can see, my identification or the private key has been saved to the lab2 file, and my public key has been saved to lab2.pub. Now let's copy our public key to our lab2 virtual machine. So I will do cat here, then the path to the lab2.public key. Let's press enter, and here is the public key. Now let's go back to the lab2 virtual machine, and I will switch to user rookie, which we just created on the system. To switch to a user, I will use the su command, then dash, then the username rookie. Press enter, and now provide the password for user rookie. Now I am logged in as user rookie, so let's create the .ssh directory, and let's create inside this directory the authorized _keys file. Let's go back to my local machine, and I will copy the public key, which I just created with the private key, and let's add it here. Let's save the file. Okay, now let's test connecting to lab2 virtual machine using the private key we just created. To do so, I will type ssh -i, then /home/turkey/.ssh/lab2, which is our private key, then rookie at 192.168.0.223, which is my Windows machine IP. And because like I did the port forwarding, so I will add here ssh-p2224. Now let's press enter. And as you can see, I managed to connect it to lab2 virtual machine using the public private key we just created. So I don't need a password to connect to lab2 virtual machine. Let's exit here. And now we are ready to disable the password authentication by editing the sshd_config file. So let's exit, and let's type sudo nano /etc ssh, then sshd_config. Let's click Ctrl W, and let's search for password authentication. And as you can see here, the password authentication is set to be yes, which means that I can access this system using username and password. To disable the password, I will set this to be no. Now let's save the file, and let's restart the sshd service to apply our changes. So I will type sudo systemctl restart sshd. I didn't get any error message, which is a good sign that SSHD service has been restarted successfully. To verify our work, I will try to access SSH using a password for the user rookie from another terminal. So let's open the terminal, and I will provide the SSH rookie at 192.168.0.223, then -p2224. Now press enter, and as you can see, it didn't ask me for a password because I can't access it with a password because we have disabled password authentication in the SSH configuration. Now let's verify that we can access the system using the private key. So let's provide the SSH -p2224, then -i, and the path to the private key, then user rookie at 192.168.0.223. Now press enter. As expected, the private key method works. Through this, we have learned together how to prevent the root user from accessing SSH remotely and how to disable password authentication for SSH. There are other measures you can take to secure SSH. One of these is to restrict access to SSH port to a specific IP, which could be your VPN IP. As we saw in our previous lessons on VPN, one of the use cases of a VPN is to restrict access to services. You can configure your firewall or security group to restrict access to SSH port from a VPN IP, a static IP, or your internal network IP range. That brings us to the end of this lesson. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson. We are still working on the task of regular audit of SSH access logs. In this lesson, we will develop a bash script to monitor SSH failed password attempts. So let's start developing our monitor shell script, and let's begin with the shebang. Next, I will define the log file path, threshold, and the Slack webhook URL. So here I'm defining the log file path, which is /var/log/secure. Then the threshold equal 5. And I will set a condition on this threshold. So whenever we have a failed login attempts bigger than the threshold we have here, a notification will be sent to Slack. Then the Slack webhook URL and the host name to get the virtual machine hostname. Now I will define a function to send messages to Slack. Do define a function, type send to Slack, send to brackets, and provide your function code between the two curly brackets. So this function will be called when I want to send a Slack message. Now let's check for suspicious login activities. So here I am printing a message checking for suspicious SSH login activities. Then this awk command will be executed. This command is used to extract, count, and sort the IP addresses from which there have been multiple failed SSH login attempts. Then using the if condition, I am checking the count, and if it's greater than the threshold we have set here, which is 5. So if the count is greater than 5, then I will define a message with the value the hostname suspicious activity detected, then the count failed login attempts from IP, then the IP. And after that, I will print the message, and I will use the send to Slack function to send the message to Slack. Now that we have finished the script, let's test it. I have already copied the script to the lab2 virtual machine. So from here, let's do cat /scripts ssh audit.ssh, and here is my script. And I have provided the Slack webhook URL, and don't try to test this webhook URL because after I finish the recording of this course, I will delete this webhook. Now let's execute the script. So let's type scripts ssh_audit.ssh or .sh, sorry. Now press enter, and as you can see, it printed checking for suspicious SSH login activities, and our message is the hostname for this virtual machine, which is lab2, then suspicious activity detected, 8 failed login attempts from IP, then the IP. Now let's verify our work from Slack. So let me bring the Slack here, and as you can see in the ops-alerts channel, I can see a new alert from the script we have developed with the same message, lab2 suspicious activity detected, 8 failed login attempts from IP 10.0.2.2. By this, we come to the end of this lesson. Your assignment for this lesson is to execute this script in a cron job that will be executed every 5 minutes. Thank you for watching, and see you in next lesson. Hello and welcome to a new lesson on how to install pre-tunnel on Ubuntu 22. For more details about pre-tunnel, visit pretunnel.com. Documentation is available at docs.pretunnel.com/docs. You can also access the documentation from the main homepage of pretunnel.com by clicking documentation. In documentation, you will find all the details and instructions you need about installing and configuring pre-tunnel, including advanced topics. Now, let's return to the homepage of pre-tunnel and let's scroll down to the install section. This section provides instructions for installing pre-tunnel on various Linux distributions. I will be installing and configuring pre-tunnel on Ubuntu 22, but feel free to select a different Linux distro. After selecting Ubuntu 22, I will find the commands to execute on Ubuntu to install pre-tunnel. Let's open our terminal. I have created a virtual machine on Amazon Web Service to serve as my pre-tunnel VPN server. The first command we will execute together is to configure the hostname on this machine. So let's type sudo hostname ctl set -hostname, then vpn.linuxdirection.com, then -- static. Next, let's verify our new hostname by executing hostnamectl. As you can see from the output, the static hostname is vpn.linuxdirection.com. You can also execute hostname to print out the machine's hostname. As you see, hostnamectl provides more information about the machine, such as virtualization type, operating system, and system architecture. I own the linuxdirection.com domain and have created the subdomain vpn.linuxdirection.com. Then created an A record for it to point to the public IP of this virtual machine on Amazon Web Service. You can install and configure pre-tunnel without a domain name, but in my use case, I will configure pre-tunnel with SSL to securely access the dashboard. Now let's update the system with sudo apt update. Going back to the pre-tunnel homepage, I will copy the commands under the install section to install pre-tunnel. I will pause the video until I finish the installation following these instructions. It is just a matter of copying and pasting commands, so I will see you in a moment. I am back. I have installed pre-tunnel and MongoDB following the installation instructions on pretunnel.com. Now let's start the pre-tunnel and MongoDB services. So let's execute sudo systemctl start pre-tunnel, then MongoDB. Now let's enable these services to start automatically when the system boots. So I will execute the same command, but I will provide enable instead of start. Having installed the pre-tunnel and started the necessary services, if you want to follow best practices, which is advisable, you should separate MongoDB from the pre-tunnel server. This means having another virtual machine for MongoDB or using a managed MongoDB service. More information on separating MongoDB and pre-tunnel can be found in the pre-tunnel documentation. Now let's open a web browser and navigate to the public IP of the pre-tunnel server or virtual machine. You will see a security warning, which is normal in this case. Click Advanced, then accept the risk and continue. Of course, only do this for URLs you trust. We now have the pre-tunnel database setup screen. The setup key is required. There is a command to execute on the pre-tunnel server to get this key. So let's copy the command. Now let's open the terminal and let's provide the sudo pre-tunnel setup key. Now press enter. After obtaining the key, so let's first copy the key and let's go back to the browser. Now paste the key here. Also, you will need to provide the MongoDB URI. In our case, we will just click Save since MongoDB is on the same virtual machine as pre-tunnel. With that done, we reach the pre-tunnel login page. Pre-tunnel provides a command to retrieve the default username and password. Let's copy that command. Now let's go back to the terminal and I will provide the sudo pre-tunnel default -password command. Now press enter. Now I have the administrator default password and the default username. So I will copy them to a safe place. Now back in the browser, let's enter the username and password. So the username is pre-tunnel and the password I will paste it here, then click sign in. We are now at the initial setup, which we will cover in the next lesson. That brings us to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In our previous lesson, we installed pre-tunnel on an Ubuntu 22 virtual machine. In this lesson, we will complete the initial setup of pre-tunnel. Let's start by changing the default username to admin instead of pre-tunnel. Following best practices, you should choose a username other than admin, as admin is commonly targeted in brute force attacks. However, for our testing and learning purposes, using admin as a username is fine. Next, let's set a new password different from the one auto-generated by pre-tunnel. For the public IP address, I will keep it as is, since this is the public IP for the pre-tunnel virtual machine. If you have an IP version 6 address for the virtual machine, you can add it here, but I will leave it blank. I will also leave the web console port as the default 443. Now, I will enter my domain, which I have already pointed to the virtual machine IP. So if you remember, my domain is vpn.linuxdirection.com. Let's encrypt will automate the SSL configuration for vpn.linuxdirection.com. Remember, as mentioned in our previous lesson, you can proceed without a domain. If you don't provide a domain for your VPN console, you will access the console using the public IP. If you want to accept IP version 6 connections, mark the respective option. In my case, I won't accept IP version 6 connections. Now, let's click Save to save our settings. The pre-tunnel service has been restarted to apply our changes. As you can see, I can access the dashboard using the public IP, but since I configured the domain for pre-tunnel, let's type vpn.linuxdirection.com. The dashboard login page now requests a username and password. To verify the SSL certificate, let's click here. Then from Connection Secure, as you can see, verified by Let's Encrypt. Let's provide the username, then the password, and click Sign in. Since this is our first login to the dashboard, we will notice that no organizations, users, or servers are available. First, we need to add a server. Let's click Servers, then Add Server. For the name, let's type vpn.linuxdirection.com or any other name you prefer. For the DNS server, I will leave it as 8.8.8.8, which is Google's public DNS. If you have a different DNS server, feel free to provide it here. I will leave the port and protocol as they are. I will also leave the virtual network settings as they are, though you may need to change these after discussing with your network team or based on your use case. Any user connected to this VPN server will be assigned an IP from 192.168.226 IP range. I will enable DNS routing. This feature ensures that DNS requests from users connected to this VPN are resolved via the VPN, adding a layer of security since their ISPs won't know the DNS requests made. This is also helpful for resolving internal domains in your organization, like example.localhost, to manage This, you would need to use your local DNS resolver instead of Google's public DNS server. Let's enable Google Authenticator for an additional layer of security for our users. Now let's click Add to add the server. The server has been added successfully. You can see information about this server, such as its status, which is currently offline, uptime, online users, and connected devices. If you want to change any configurations for the vpn.linuxdirection.com server, click its name, and you can then change any of the configurations. Let me click cancel because I don't want to change any of the configuration we already did. Now let's add an organization. Click users, then add organization. Let's type first org, then click add. As you can see, the organization has been successfully added. Let's go to servers to attach the organization we just created to the server. To do so, let's click attach organization. We have the first org and the server we just created, so I will just click attach. As you can see, successfully attached organization. After attaching the organization to the server, we can start the server. Let's click Start Server. Here, you will see logs about the server, which are very important for troubleshooting. You have options here to manage the server, like restarting or stopping it, or deleting it if needed. The status of the server is now online. With this, we have completed the initial setup for pre-tunnel, including adding a server and creating and attaching an organization to a server. That's it for this lesson. See you in the next lesson. Hello and welcome to a new lesson on creating a VPN user profile. Recall that in our previous lesson, we completed the pre-tunnel initial setup, creating a server and an organization, and attaching the organization to the server. In this lesson, we will start by creating our first user, and you can create multiple users using the same method. To create a user, click Users. Any user you create will be shown here. You can create a single user or multiple users at once. I will click Add User to create our first VPN user. Let's type Adam as the username. We have one organization which we created in our previous lesson, so I will leave that as it is. The email is optional, but I will provide Adam's email here. For the PIN, think of it as a mobile PIN or a debit card PIN, some digits that act as a password for authentication. I will leave it blank since I already have two-factor authentication set. I don't want to complicate things for the user. Also, the user can set the PIN later when downloading his profile if desired. Now, click Add to add the user Adam. Once you create a user, they will be shown here with some information like never, indicating that this user has never connected to the VPN. You can also see if the user is currently online or offline. Now, before downloading the user profile for testing, and remember, you should not download any user profile unless it's your own. But since we are learning and testing together, I will download Adam's profile. But first, let's go to the pre-tunnel homepage and scroll down to the pre-tunnel client. Whenever you create a VPN user profile and send the user his profile URL, you should have a guide or documentation to help him download the profile and use the pre-tunnel client to connect to the VPN. Since pre-tunnel is built on top of OpenVPN, your VPN users can also use the OpenVPN client to connect. In the pre-tunnel client section, you can find instructions on installing pre-tunnel client on different operating systems. As you can see, the pre-tunnel client can be installed on Windows, Mac OS, and various Linux flavors. I have already downloaded and installed the client for Windows. Now let's go back to the dashboard. We have created a VPN user named Adam. You can download the profile from here or get a temporary profile link. Any link from here will expire after 24 hours. So when you send any of these URLs to the user, you need to clarify that they should connect within 24 hours. If the URL expires, you can get a new valid URL for another 24 hours. Let's copy this URL and open it in a new tab. Let's assume that I am Adam and you sent me the VPN profile URL. The first thing I will do is read this QR code using my authenticator. Now I have scanned this QR code, but I advise you not to scan it, as this server will be terminated once I finish recording the lessons. As Adam, I should download the pre-tunnel client or know that I can use the OpenVPN client according to the guide you sent me. As user Adam, I can also set a pin for my profile, which I won't do. I will click Show More and then download my profile. As user Adam, I have installed the client, downloaded the VPN profile. Now let's click Import to import my downloaded profile. Now I will click Browse to select my profile from my local machine. Now I have selected my profile from my local machine. Let's click Import. Now I can see my profile, the user Adam, the status is disconnected, the server vpn.linuxdirection.com, and the organization is first.org. To connect, let's click Connect. Now I will type the authenticator passcode from my Google Authenticator. Let's click Connect. As you can see, the status is now online and I have a new public IP, which is the VPN public IP. I also assigned private IP from 192.168.226 range and my IP end with 2. Now let's verify that we are browsing the internet from the VPN IP. So let's open our browser and visit nordvpn.com/whatismyip. As you can see, the IP shown here is the VPN's public IP. So let me bring the pre-tunnel client and you can see that the IP shown from whatismyip web page is the same IP as the VPN server public IP. With that, we have learned together how to create a VPN user and verified that the user is browsing the internet via the VPN IP. That's it for this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on testing VPNs to verify our work. One of the benefits of a VPN is that it can be used to restrict access to certain ports. This means that no one can access services running on these restricted ports except via the VPN. For example, you can limit access to the SSH port to only the VPN IP or restrict access to internal services such as databases to the VPN IP. In this lesson, we will test the VPN to validate our work. I have installed an Nginx web server on a virtual machine and restricted access to port 80 to the VPN IP only, as you can see here. Now, let's try to access the web server IP from the browser. So I will type the IP of the Nginx web server here and click refresh. As you can see, I am getting the connection has timed out because I restricted access to the web server to the VPN. Now let's connect to the VPN So I will open the pre-tunnel client and click connect. But first, let's stop this one because it's taking much time. So I will click connect here. Now I am connected to the VPN. So now let's refresh the page. As you can see, the Nginx welcome page can now be accessed via the VPN. You can apply the same method with the SSH port, for example. Also, since I am connected to the VPN, I can connect to the Nginx VM SSH using its private IP. So let's open the terminal and I will provide the private key, then the user Ubuntu and the private IP of the Nginx virtual machine. Now let's press enter. And as you can see, I managed to connect to the SSH of Nginx virtual machine via its private IP. And by that, we get to the end of our lesson. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson. In our previous network config and security project tasks, we have tackled two important areas, VPN and SSH auditing. Now you should have a good idea of why security is so vital in your work, especially in Linux. As we finish these topics, remember setting up and checking on VPN and SSH are ongoing tasks. They are really important in Linux, where you often have more control over your system. Staying on top of these tasks helps keep your network safe. Thanks for working hard on these tasks. You have learned some key security skills that are super useful in Linux environments. Keep using what you have learned, stay safe, and continue to grow your Linux skills. So now let's move the two tasks to be done. And by that, we get to the end of our lesson. Thank you for watching and see you in next lesson. Hello everyone. In this lesson, we have a new task to configure and set up a Laravel project with Nginx and MySQL on Ubuntu. This task, assigned to me by the development team, involves setting up and configuring a Laravel project environment. So let's open the task. As you see from the description, the primary goal of this task is to set up and configure a Laravel project environment, including the installation and configuration of Nginx, PHP, MySQL, and an SSL certificate, all on an Ubuntu server. You will find details on how each component should be installed and configured for this task, along with specific versions for MySQL and PHP. To complete the task, we should have MySQL, PHP, Laravel, and Nginx installed and configured. We will also configure SSL to secure the website. So let's move the task to be in progress and see you in the next lesson. It seems an excited project for me, and I am sure that you will learn a lot from it. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson on creating an SSL certificate. In this lesson, I will demonstrate how to get an SSL certificate from SSLS.com. They provide a 30-day SSL trial, which I will use in this lesson. The decision to get an SSL certificate is based on many factors, such as whether you want a single domain certificate or a wildcard certificate. We already discussed the difference between SSL types in this lesson's presentation. Now let's start our practical lesson. Here I am in SSLS.com account getting an SSL for my domain. As the description indicates, positive SSL covers both www and non-www names by default. Let's provide our domain, which is awesomeservice.net. As you see, www.awesomeservice.net has been added because this certificate covers both www and non-www, as I mentioned. You can also issue a certificate for a subdomain, but in our use case, I want it for awesomeservice.net and www.awesomeservice.net. Now click onwards. The next step is to create a CSR and private key. SSLS.com and most SSL providers enable you to create the CSR and the private key in browser. If you want to create them in the browser, click on Save Key.zip to download the zip file. Otherwise, you can select Use My CSR and you will find the command to execute in your terminal, which will create the private key and CSR. The command also shows the content of the CSR file, which you will copy and paste here in Enter CSR. For simplicity, I will create the CSR in browser. So let's select Create CSR in browser and let's click Save Key.zip. Now I have downloaded the private key. As you read, SSLS.com doesn't store the private key. So if it is lost, you will have to get your SSL reissued. Now click onwards. We need to confirm the domain to validate that I am the owner. You can confirm the domain by email, upload a validation file, or create a DNS record. I will go with create a DNS record. You can review which domain the SSL will be issued for and to which email the installation files will be sent. If all looks good, click Submit. The next step is to validate the DNS. A CNAME should be created for awesomeservice.net, so let's add the CNAME DNS record. So I am managing awesomeservice.net domain from AWS Route 53. To create new record, I will click Create Record. Then the record type will be CNAME. And let's go back here to copy this and paste it here. Then the value, I will copy the pointed to value and I will add it here. And the TTL should be 60 minutes. So I will select 1 hour and let's create the record. Now that we have added the CNAME DNS record, let's click Confirm DNS Added. The next step is to get the SSL, which may take 2 to 20 minutes. So I will pause the video until this process done. I am back, and as you see, I have a message. We have successfully verified that your website meets our provider requirements, but also like the provider needs more time, so I need to try again in 15 minutes. So I will pause the video and I will try again in 15 minutes. Now the SSL is ready for download, so let's download the SSL by click on Download SSL. We now have the SSL certificate files, including the security certificate, the BKCS certificate, and the CA bundle file. Also, I have added the private key I just downloaded from SSLS.com to the same directory that have all the certificates. Also, I have added to this directory the private key I just downloaded from SSLS.com. At any time you find this certificate suitable for your domain, you can buy it by click on the buy button here. We now have SSL for awesomeservice.net and we will use it later in this project to secure the domain. that brings us to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will learn how to install and configure a MySQL database for our project. Here I am in the VM we assigned to this project. The first thing I will do is to configure the hostname for this VM. So let's execute sudo hostname ctl set -hostname, then awesome service.net, then -- static. To verify the new hostname, let's execute hostname. And as you can see from the output, the hostname is awesomeservice.net. Now let's execute sudo apt update to update the packages. Now press enter. The packages have been updated, so let's install the MySQL server by executing sudo apt install MySQL-server. This command will install MySQL 8. Now we have MySQL server installed, so let's start and enable the MySQL server. To start the MySQL server, I will execute sudo systemctl start MySQL, and it seems that the system unable to resolve the host awesomeservice.net. So let's copy the host name and let's edit /etc hosts file, and here I will add 127.0.0.1, then the name of the awesomeservice.net host to resolve the issue. Now save the file and let's try to start the MySQL service again. Now I didn't get any error message, which is a good sign. Now to enable the MySQL service to start automatically when the system boot, I need to enable the service. So I will execute sudo systemctl enable MySQL. I want to use MySQL native password, so let's execute sudo MySQL to connect it to the MySQL command line interface. Let's execute the following command to enable MySQL native password and also set the MySQL root password. So this command will alter the user root. It will enable the MySQL native password, and also it will set the root password for MySQL to be this password shown here. Now press enter. Now let's exit the MySQL command line interface by executing the exit command. Now that we have MySQL installed on the virtual machine, let's do the initial secure installation by executing MySQL _secure installation. Provide the MySQL root password we just set a moment ago. I don't want to validate the password component, so I will just press enter. Following best practices, you should validate the strength of the password. But since this is a playground for us, it's fine to not validate the password component. Change the password root? No, so I will just press enter to use the same MySQL root password we just configured. Remove anonymous users? Yes. Disallow root login remotely. Even if this is a playground, I will follow best practices for this one, and I will disallow the root login remotely. So I will type yes and press enter. Remove the test database and access to it. Yes. Reload privilege table now. Yes. And as you can see, all done. Now we have MySQL 8 installed on this virtual machine. That's it for this lesson. In the next lesson, we will learn together how to create a database, username, and password so that we can configure Laravel later. Thank you for watching this lesson and see you in the next lesson. So we have seen together in our previous lesson how to install MySQL Server 8 on Ubuntu. In this lesson, we will continue preparing our environment for installing the requirements needed for our project. Let's create a database username and password. First, we need to log into the MySQL command line interface by executing MySQL -u. Then I want to log in as a user root, then -p to provide a password. Let's provide the MySQL root password we set in the previous lesson. And now I am logged into MySQL and I can use MySQL command line interface to manage the MySQL. As you can see here, we have installed MySQL version 8.0.35. To create a database, type create database, then the name of your database. I will name it Laravel_DB, then semicolon, and press enter. I didn't get any error message, so it's a good sign. To validate the creation of the database, type show databases, then semicolon, and as you can see from the output, the Laravel_database has been created. Now let's create a user for this database. So I will type create user, then the username, and this user will have access on localhost. So I will type localhost, then identify it with the MySQL native password, and here is my super secure password, which is password 123456. Please don't use a simple password in your environment. I just use simple password in our playground for simplicity. Now press enter, and I didn't get any error message, so it's a good sign. The next step is to grant permissions on Laravel database to user Laravel_user. So executing this command will grant all privileges on the Laravel_database, all tables to the Laravel user. Let's press enter. Now let's execute flush privileges and let's exit the MySQL command line interface. To validate our work, let's log into the MySQL command line interface using the username we just created. So I will type MySQL -u, then the username I want to connect to MySQL command line interface with, which is the user Laravel_user, then -p. Now let's provide the password we have set for user Laravel_user. And from the MySQL command line interface, let's show available databases. And the command should be show databases. And I will copy the Laravel_database and I will type use, then the database name and semicolon. As you see, database changed indicates that user Laravel_user has permissions on Laravel_database. Easy peasy, right? By creating a database, a user, and adding permissions for the user we created on the database, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Right now we have installed and configured MySQL. We have created a database and user for Laravel. So it is time to install and configure Laravel. Let's first update the packages on the system by executing sudo apt update. Let's install PHP with the required packages for Laravel. So I will execute sudo apt install PHP and some PHP modules like PHP mbstring, PHP XML, PHP BCmatch, and PHP curl. This command will install PHP 8.1. You may need to check with the development team what are the requirements for PHP, MySQL, and Laravel versions to ensure you have met their requirement. If the requirements are not clarified in your task, then don't be shy and ask for a clear requirement. Now let's validate PHP installation by executing PHP -v. And as you can see from the output, PHP version 8 1.2 is the version we have installed. Next step is to create Laravel project. Let's first create the /var/www directory. So I will execute sudo mkdir/var/www. Then change the owner and the group for /var/www to be Ubuntu by executing the command sudo chown ubuntu dot -r capital /var/www. Now let's validate the owner and the group. So I will execute ls-ld /var/www. And from the output, you can see that the owner is Ubuntu. Also, the group is Ubuntu. Now let's change directory to /var/www by executing cd /var www. Let's install PHP Composer by executing sudo apt install composer. And finally, we are ready to create the Laravel project. So I will execute composer create project --prefer-dest Laravel/Laravel, then the name of the project, which will be awesome service. So this command will create a Laravel 10 project. As I mentioned before, you may need to check the version needed by your development team before you proceed with the installation. Now let's execute ls-l. As you see, we have a new Laravel project named Awesome Service as we expect. Let's change directory to Awesome Service by executing cd, then Awesome Service. Now let's execute PHP artisan. So I will type PHP artisan -v capital to confirm the installation. As you see from the output, the project is Laravel 10.39.0. To configure Laravel, we need to edit .env file. So let's execute ls.env *. As you see, we have .env file, which is the main file for Laravel configuration, and we have .env.example, which have some configuration as examples to help you configuring Laravel. Let's edit .env file using our favorite editor. So I will execute nano.env. Now let's change the application name to be Awesome Service and the application environment to production. And you can set this to the application environment. It may be staging or testing or development. In our use case, this is a production environment. For the app URL, it will be https, and this will be awesomeservice.net. Also, it is necessary to configure the database connection. So the database host, it's on the same virtual machine. So it will be as is 127.0.0.1, the default port as is. And the database name is Laravel_DB. The username is Laravel_user, and the password. So let me copy the password of the user Laravel_user, and I will paste it here. Now let's save the file, and by that we get to the end of this lesson. Thank you for watching, and see you in next lesson. It is time now to install and configure Nginx for our project. So let's install Nginx by executing sudo apt install Nginx. Now we have installed the Nginx. Let's edit the main configuration of Nginx. So let's type nano/etc nginx I will change the user running Nginx by changing www-data to be Ubuntu. Let's save the file and let's enable and start Nginx. So let's type sudo systemctl enable Nginx so that Nginx can be run automatically when the system boot. And I will run the Nginx service by executing sudo systemctl start Nginx. I also want to install the PHP FVM, so I will type sudo apt install php-fvm. Now let's start the PHP FVM by executing systemctl start php 8.1-fvm. I will also enable the service so it can be started automatically when the system boot. So I will execute the same command, but I will provide enable instead of start. Now let's edit the PHP FVM configuration file. So let's execute sudo nano /etc php then fvm, then the PHP version which is 8.1, then fvm, then rule.d, then www.conf. I will change the user and the group to Ubuntu. So let's scroll down to user, and this one will be Ubuntu. Also, the group will be the same, Ubuntu. Then let's scroll down to the lesson owner and group, and I will change them also to be Ubuntu. Now let's click Ctrl X, Y, and enter to save the file. And let me restart the PHP FVM because I did some modification in its configuration. So I will do systemctl restart php 8.1-fvm. Now let's create the nginx configuration file for awesomeservice.net. So I will execute sudo nano /etc nginx conf.d, then awesomeservice.net.conf. So I pasted the content of awesomeservice.net.conf. Let's save the file. You can find this file in our course GitHub repo as a reference for you. Also, I will attach to this lesson a resource explaining the configuration in this file in detail. Now let's create the SSL certificates directory on our web server. So let's type sudo mkdir /etc ssl, then the awesome service directory, which will have all the certificates and private key for awesomeservice.net. Let me also change the owner and the group of this directory to be Ubuntu. So I will execute sudo chown ubuntu -r /etc ssl awesome service. Now let's change directory to the awesome service SSL directory. So let's type cd /etc ssl, then awesome service. So what I will do in this directory is that I will create files to represent each file from my certificate. So I will create the private key, which will be a copy from the private key, the same for the certificate, and also the same for the CA bundle. But I will not show you the content of those files. So I will pause the video until I create the files, then I will come back. So I am back and I have created the CA bundle file and the certificate file and the private key, and I have copied the content from the files I have downloaded from ssls.com to those files. Now let's validate our nginx configuration before restarting nginx. To do so, I will type sudo nginx -t. And it seems that I have an error in my configuration, and it's related to awesomeservice.com.ca bundle, and this file is not, or it doesn't exist. And of course, because like the name of the file should be .net, not .com. So let's edit the nginx configuration file for awesomeservice.net, and let's go to the SSL trusted certificate and change the .com to be .net. Now let's save the file and let me execute the sudo nginx -t again. And as you can see, the syntax is okay and the test is successful. The next step is to create a record for our main domain to point to the web server. So let's do it. So here from the Route 53, which manages the awesomeservice.net DNS for me, I will create a record, and this record will be a record for awesomeservice.net, and it will point to the public IP of the virtual machine I have installed and configured Nginx on it. So let's create our first record, and also let's create another record for the www. So I will type here www.awesomeservice.net, and it will point to the same public IP of the Nginx web server. Now create records, and now I have two records, one for the awesomeservice.net and the other one for www.awesomeservice.net. Now let's restart the Nginx service. So I will type sudo systemctl restart Nginx. Now it's the time to open the web browser to validate our work. So I will type www.awesomeservice.net in the web browser and press enter. As you can see, Laravel is shown up and our domain is secured using the SSL certificate, which I can validate from this icon. So let's click on it and let's click connection secure. And as you can see, this certificate is verified by Sectigo Limited. You can also see more information about the certificate, which will bring you here to the website and also verified by Sectigo Limited. You can also verify the SSL certificate online from SSL Checker. So let's copy the domain and go to sslchopper.com/ssl-checker.html, and here provide the domain and check SSL. And as you can see, the certificate was issued by Sectigo and it will expire in 1 year. That's in case I bought the certificate from SSLS.com. If you didn't buy the certificate from SSLS.com within 30 days, then your certificate will expire. And by having a running Laravel configuration with SSL, we finish our tasks for this project and get to the end of this lesson. You should now update the development team so that they can start doing their magic. Thank you for watching and see you in next lesson. As we come to the close of our series on setting up and configuring a Laravel project with Nginx and MySQL on Ubuntu, I would like to take a moment to reflect on what we have accomplished. Throughout these lessons, we have navigated through the complexities of setting up a robust production environment. From installing MySQL and PHP to configuring Nginx and securing our site with SSL. Each step has been a building block towards creating a fully functional Laravel application. I hope these sessions have not only equipped you with the technical skills needed, but also inspired confidence in managing and deploying web applications. Remember, the journey doesn't end here. Experiment with what you have learned, explore new features, and continue to grow your skills. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson on antivirus and vulnerability management overview. In today's digital landscape, businesses rely heavily on Linux systems to power their operations. However, with this reliance comes increased vulnerability to cyber attacks. Antivirus and vulnerability management are essential for safeguarding Linux environments. ClamAV and Vaults are powerful tools that can help you protect your Linux systems from malware and vulnerabilities. Antivirus software is crucial for detecting and neutralizing malware threats. Vulnerability management focuses on identifying and remediating security weaknesses in your systems. These two approaches work together to create a comprehensive cybersecurity strategy. Now let's move on to ClamAV. ClamAV is a free and open source antivirus engine that offers real-time protection against malware. It is compatible with various Linux distributions and can be integrated with popular firewalls and mail servers. ClamAV's community-driven nature ensures continuous improvement and bug fixes. Let's discuss the benefits of ClamAV. ClamAV's community-driven nature ensures ongoing updates and fixes. Its real-time protection provides proactive defense against emerging threats. ClamAV's seamless integration with Linux systems ensures broad coverage. Its flexible configuration allows tailored protection for unique environments. What about the use cases for ClamAV? ClamAV effectively protects server systems from malware intrusions. It safeguards desktop systems and workstations from malware infections. ClamAV helps protect network infrastructure from malware propagation. Now let's move on to Vulse, which is a centralized vulnerability management platform. Vulse is an open-source agentless vulnerability scanner that provides a comprehensive view of security risks across your Linux systems. It can be run on-premises or in cloud environment. It scans your system for known vulnerabilities, generates detailed vulnerability reports, and helps you prioritize and remediate critical issues. Let's discuss the benefits of Vulse. Vulse offers a centralized view of security risks for holistic risk assessment. Its automated vulnerability scanning ensures continuous monitoring and identification. Vulse provides detailed vulnerability reports with insights for effective remediation planning. What are the use cases for Vulse? It generates compliance reports to meet regulatory requirements. Vulse enables regular system audits to detect potential security weaknesses. Now let's move on to the alternative tools for antivirus and vulnerability management. Several alternative antivirus and vulnerability management tools are available. Bitdefender Antivirus offers comprehensive protection against Linux threats. Sophos Antivirus for Linux provides real-time defense against malware and zero-day attacks. F-Secure Antivirus for Linux defends against advanced malware threats and protects rooted systems. Now to the conclusion. Antivirus and vulnerability management are crucial for protecting your Linux systems. ClamAV and Vulse are powerful tools that can help you safeguard your system from malware and vulnerabilities. Explore and implement these tools to enhance the security of your Linux environment. And by that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on our antivirus and vulnerability management project tasks. We have two main tasks for this project. The first is the deployment and management of antivirus software, and the second is managing system vulnerabilities. First, let's look at the antivirus task. This task involves deploying and managing antivirus software to protect our Linux environments against malware threats. It includes three sub-tasks: installing and configuring ClamAV, performing system scans, and setting up real-time scanning and notifications. We will learn a lot from these activities. Now let's mark this task as in progress. And let's move on to the second task. The second task focuses on managing system vulnerabilities to uphold high security and compliance standards. Here we will cover the installing and configuring of vaults, running vulnerability scans, and analyzing reports. Let's also set this task to in progress. Working on this project will be enriching, and by the end, you will have the knowledge to build a robust antivirus and vulnerability platform for your Linux environments, safeguarding your company's business. Thank you for watching, and I look forward to seeing you in the practical lessons. Hello and welcome to a new lesson on installing ClamAV on Rocky Linux 9. The first step is to update the system to the latest version of the package list. To do so, run the following commands. The first command is sudo dnf check-update. And our second command is sudo dnf install dnf-utils to install the dnf utilities. And our third command is sudo dnf install eper release to install the eper release repository. So I misspelled the release. Let's execute the command again. And as you can see, it seems that eper release is already installed on Lab4 virtual machine. The next step is to install ClamAV by executing sudo dnf install ClamAV clamd clamav-update. To verify the installation, let's execute clamd --version. And from the output, we can see that ClamAV version is 1.0.4. If you have SE Linux enabled on the system, you need to configure it to allow ClamAV to scan the system. To check SE Linux on Red Hat family, let's execute SE status command. From the output, we can see the current mode is set to enforcing, which means we need to configure SE Linux to allow the antivirus to scan the system. So to configure SE Linux to allow the antivirus to scan the system, we need to execute the following command. Sudo set se pool -p antivirus _can_scan_ system, then 1 to enable this feature. Now press enter, and now we configure the SE Linux to allow antivirus to scan the system. It is good practice to update the virus definition when you install ClamAV, and also update the virus definition regularly so that your system is protected against new viruses. To do so, let's execute sudo fresh clam. Now press enter. This may take a couple of minutes, so I will pause the video and I will come back once the update process is done. After the database has been updated, you can start the ClamAV fresh clam service, so it keeps updating the signature database in the background with the following command. So let's start the service by executing sudo systemctl start clamav-fresh clam. Now press enter. Now let's check the status of the service, so I will execute the same command, but this time I will type here status. And as you can see, the service is running since 10 seconds and it's also disabled, so we need to enable the service by executing sudo systemctl enable clamav-fresh clam, and we enable the service so that it can be started automatically when the system boot. That's it for this lesson. It's pretty simple and straightforward to install ClamAV on Linux. Thank you for watching and see you in the next lesson. In our previous lesson, we learned how to install ClamAV and update the database signature. In this lesson, we will learn how to scan the file system with ClamAV. To scan a directory, let's execute sudo clam scan, then -r because we are going to scan a directory, then the path to the directory. So in this case, I am scanning /temp. Now press enter. It may take a couple of moments to finish, and the scan speed depends on the available resources in the machine you scan. Clam scan consumes memory, so if you execute the command on a machine with less than 2 GB of RAM, it will take time to finish scanning. Now let's check the scan summary. In this summary, you can see the known viruses in the ClamAV database signature, which means it scans your system against 8 million viruses. From the summary, you can see how many directories and files were scanned, the data scanned, and the number of infected files, which is 0, and that's good, of course, unless you are happy with having viruses on your system. You can also see when the scan starts and when it ends. Now let's test ClamAV with a virus test file from eCar. This file is not actually a virus and can be downloaded from ecar.org. Let's create a directory. So I will execute mkdir, then the directory name is dir1. Now let's change the directory to dir1, so I will execute cd dir1. Let's download the virus test file using the curl command, and don't worry, I will provide the URL and the curl command as attached resource to this lesson. So I am downloading the virus test file from ecar.org, and I will name the file infected_file.txt. Now let's press enter. Let's view the file. So I will execute cat, then infected_file.txt. As you see, the file has a signature that can be detected by antivirus software for testing purposes. The file is not harmful, but also use it with caution and don't use it in any production systems. Now let's scan this file. So let's execute sudo clam scan, then the file name, which is infected_file.txt. Now regarding the scan result, as you see, ClamAV detected the infected file and shows the file path, the virus name, and the number of infected files. If you find an infected file, you can remove the threat found inside the file, which will delete the file by executing sudo clam scan -remove, then the infected file name, which is in our case is infected_file.txt. Now press enter, and from the output you can see that ClamAV detected the virus in infected_file.txt, then it removed the file. So if we executed ls and enter, as you can see, we don't have the infected_file.txt file anymore. To know what options you can use with the clam scan command, let's execute clam scan, then -h. And from the output, you can see that you can save the scan report to a file using -l, then the log file name. You can also move or copy the infected file into a directory using -move or -copy. So take your time reviewing all options you can use with clam scan to see what options are suitable for your use case. Let's see how we can save the scan report to a file. So first, let's create a directory for our report. So let's execute sudo mkdir, then var log clamav. And now let's execute the clam scan command, providing the report file to save our report to. So let's execute sudo clam scan, then I want to execute home vagrant, then I will provide -l option, which enable me to save the scan summary to a log file or to a report file. Then the path to this report, which will be under var log claim AV, then claim scan.log. Now press enter. As you see from the output, claim scan finished scanning /home/vagrant. It also printed out the scan summary, and also it saved this summary inside the claim scan.log file. To validate that, let's view the content of claim scan.log. So I will copy this path, and here let's execute sudo cat then /var/log/claimav/claimscan.log. Now press enter, and as you see, now we have the scan summary inside the log file. Now each time you execute claim scan with the -l option to save the report to claimscan.log, the new result will be appended to claimscan.log file. Over time, the file won't be readable, so you may need to find a way to save the report in separate files each time you execute claim scan. And that's what we will do in our next lesson. Thank you for watching, and see you in the next lesson. Hello and welcome to a new lesson. We are still exploring claim AV together, and in this lesson we will develop a bash script to scan the system and then send us the result on Slack. Also, we will add this script to cron tab so that it can be executed to scan our file system every day at midnight. Let's start the lesson by creating a script directory on this virtual machine. To do so, I will type sudo mkdir then /scripts. Now let's change the owner and the group to be for Vagrant. So I will type sudo chown -r vagrant dot then /scripts. I will develop the script here on my local machine using Visual Studio Code, then I will copy it to the virtual machine. As usual, let's start the script with a shebang. The next instruction in our script is to define the log path. So let's define a variable log_file equal, then I will save the log file to /var/log/claimav/claimscan_, then the date when I will execute this script, then .log. Next, I want to run a claim scan and save its report to the log_file variable. So to do so, I will type sudo claim scan, then /home/vagrant. The path I want claim AV to scan, then -l to provide the path to my report, which I will save the claim AV scan summary to it. Then of course, this path will be the value of log_file variable. The next instruction is to read the content in log file and save it to a variable. So I will define a variable here, log_content, and this variable value will be the output from the command sudo cat then the log file. Now I want to save the hostname to a variable, so I will define a variable with the name hostname, which will equal the output from the command hostname. I want the hostname here because I want it to be sent with the report to Slack so that I can know the scan result for which hostname. Now let's define the Slack webhook URL variable. So I will define a Slack webhook URL variable, and the value will be my Slack webhook URL. Now the Slack message will be claim AV. So let's define the Slack message variable, which will be claim AV scan result 4. Then it will print the hostname, and in the new line it will print the content of the log file report. Now to the fun part. To communicate with Slack via its webhook to send our notification message, let's use the curl command with the post method, then the content type application JSON, then the data we will send to Slack, which will have the text or our Slack message, then we provide the Slack underscore webhook URL so that we can communicate with the Slack and send our alert to it. Now let's copy the script we have developed together to the virtual machine. So on the virtual machine, I will type nano/scripts, then clamav underscore scan.sh and press enter. And it seems that I don't have nano installed here. So let's install it using sudo yum install nano. Now we have nano installed, so let's execute nano/scripts/clamav underscore scan.sh. Now let's copy the script we have developed to our virtual machine. And all looks good. Let's save the file. Now let's make our bash script executable by executing chmod +x, then /scripts clamav underscore scan.sh. Let's test our script before we add it to cron tab. As you can see, we developed a script to scan/home/vagrant. So let's first download the virus test file to validate our work. So I will provide the curl command to download the virus test file, and the file name will be infected_file. We can check the file here. So as you can see, we have the infected_file. So now let's test our script as I mentioned before. So let's /scripts, then clamav underscore scan.sh. As you see, the script finished and it printed out the scan summary, and also we see the OK here, which means that the script executed successfully without any error. Now let's validate our work by checking our Slack channel. As you see, we received the scan result on Slack and it shows the host name, which is lab4 in our use case. Now let's go back to the terminal and let's execute cron tab -e to add our script to it. And I will press I to insert inside the cron tab. And to execute the clamav underscore scan.sh script every day at midnight, I will provide 0, 0, then asterisk, 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 then the path to the script, which is scripts /clamav underscore scan.sh. So this script will be executed every day at midnight. Let's save the cron tab. Now we need to restart the cron service to apply our changes. To do so, I will execute sudo systemctl restart cron d. Right now, clamav will do a daily scan on your system and it will send you the scan report to Slack so that you can be aware of any infected system and take immediate actions to protect your system. By that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will learn how to configure clamav for real-time scanning. Let's start the lesson by editing the main configuration file for clamav. First, open the configuration file. To do so, let's type sudo, then nano, then the path to the main configuration file of clamav, which will be etc/clam.d, then scan.conf. Now let's go to the end of this file. Now let's provide the following lines: local socket /run/clamd.scan/clamd.sock. This specifies the path to the Unix socket file that clamd uses for inter-process communication. Then let's provide the on-access include path /backup. The on-access include path is used with clamav on-access scanning feature. It defines which path should be monitored for real-time scanning. In our use case, we are monitoring the /backup. You can provide more than directory, but you need to provide them in a new file. So for example, let us say that you want to scan /home/vagrant, then you will provide the same on access include path, then /home/vagrant. But in our use case, I want only to monitor the /backup. Now let's provide the log file, which will be /var/log/clamd.scan. And after defining our log file, let's define the on-access exclude username, then the username clam_scan. The on-access exclude username are used to specify which usernames and processes running under these usernames should be excluded from on-access scanning. Without this option, the service won't start. Now let's save this file. And after saving the file, the next step is to create the backup directory. The backup directory might be a directory that stores your backups, and you want to scan all backups to ensure there are no viruses in any of them. Another use case is that you have a shared folder between multiple users. This shared folder can be an FTP folder or a shared file system like NFS. And you need to ensure that all files added to this shared folder by users are immediately scanned. To create the backup directory, let's execute sudo mkdir then /backup. Now let's restart the clamd service by executing sudo systemctl start clamd add scan.service. Let's also enable the clamd service by executing sudo systemctl enable then the clamd add scan.service. And let's start the clamav on access service by executing sudo systemctl restart clamav-clam on acc.service. Also, let's enable this service so that it can be started automatically when the system boot. Let's test the real-time scanning. So let's go to backup. So I will execute cd/backup. Now let's download our favorite test virus file from ecar using sudo then the curl command. Now that we have the file, let's check the logs. So I will execute sudo cat then /var/log/clamd.scan, and this is the log file we have defined inside the main configuration file of the clamav service. Now press enter. As you can see, the file has been detected by clamd once it's created in /backup, which validates our configuration for real-time scanning. Now any new file created or added to /backup will be scanned immediately. I think you might have the same thoughts as me right now about developing a script to notify us on Slack in real-time scanning. Let's do it in the next lesson. For now, we have seen how to configure real-time scanning, and by that, we get to the end of this lesson. Thank you for watching, and see you in the next lesson. Hello and welcome to our new lesson. In this lesson, we are going to write a bash script that monitors the log file for malware detections and sends alerts to Slack channel. Let's start. First, we write the shebang. And this line tells our system to use bash to execute the script. Next, we will set up our Slack webhook. So let's define a variable Slack_webhook_URL. And of course, I will provide the Slack webhook URL once I copy this script to our virtual machine. Now let's specify the log file clamav uses. So let's type log file, which is a variable, and the value for this variable will be /var/log/clamd.scan. This is where clamav records its activity. Then we need to define what we are looking for in the log. So let's define the search pattern variable, which will be search_pattern equal found. This pattern indicates a malware detection. Let's also keep track of the last processed line to avoid duplicate messages. So let's type last_line_processed equal then empty string. We want to include the name of our machine in the alert. So let's type hostname equal $2 braces hostname, and this command fetches the hostname. Moving on to the main part of our script, let's type sudo tail -f and 0, then the log file value, then pipe and while readline semicolon do. This command reads the log file in real time, passing new lines to our while loop. Inside the loop, let's add an if condition. So here is our if condition, which will check if the line contains the found pattern and is not a line we have already processed. When we detect malware, we need to alert our team on Slack. So let's define the Slack message variable, which will be malware found on, then the host name and the line detected in the log file. Then to send this message, we will use the curl command to post a message to the Slack using the Slack webhook URL. Now let's close the if statement and finally close the loop with done. With this, our script is all set to continuously monitor for threats and keep our team updated via Slack. Now we have finished our script. Let's test it. So I will copy the script to the lab for virtual machine. So let's copy the content of the script here. And from the lab for terminal, let's do nano/scripts, then clam av_monitor.sh. Let's paste the script code here, and now let's save the file. Now let's make the script executable. So I will execute chmod +x, then the path to the script, which is /scripts clam av_monitor.sh. Now let's execute the script. So I will do /scripts /clam av_monitor.sh. From another tab, let's go to backup directory and download the virus test file with sudo curl command, and we will download the file from ecar.org, and I will name the file test_infected_file. Now press enter. And let's ls to verify that we have the test infected file. Now let's go back to the terminal where we executed the script, and it seems that we have an error message here, no URL specified. And of course, this problem is because I didn't provide the Slack webhook URL. So let's fix that quickly. So I will do nano scripts clam av_monitor.sh, and in the Slack webhook URL, I will provide the Slack webhook URL. Now let's save the file. Let's execute the script again. And let's go back to the terminal where we downloaded the test infected file. Let me remove the file. And let's download the file again. Now let's go back to the terminal. Let's go back to the terminal where we executed our script. As you see, it worked, which means it found something and sent it to Slack. Let's bring our Slack channel here. As you see, we received the alert clarifying the host name and the infected file. Now we need to ensure that our script can be run as a service to make sure that it's always running even if the system boots. So let's create a service for our script. Now let's go here and I will click Ctrl+C to terminate the script. Now let's create a new systemd system file. So let's type sudo nano etc systemd system, then clam av_monitor.service. Now press enter. And let's provide the clamav_monitor.service file, and you will find this file in the repository. So here in the file, I'm giving a description, which is clamav log monitor, and under the service, the execution start will be bash, then the pass to our script, and the restart, it will be always, and under install wanted by multi-user.target. Let's save the file, and now let's enable and start the service. So to enable the service, I will do systemctl enable, then the service name, which is clamav_monitor. Now let's start the service, and let's check the status of the service using systemctl status clamav_monitor. And as you can see, the service is enabled and it's active and running since 8 seconds. Now let's go back to the other terminal, and let's download again the virus test file, but this time I will name it infected file _2. Now we have downloaded the file. We should see a notification on Slack. Let's validate our work. So I will bring the Slack channel here. As you can see, we received the alert. I think now we will see how powerful clamav is and how it can protect your system. And with that, we get to the end of this lesson. Thank you for watching, and see you in the next lesson. Hello and welcome to a new lesson on installing Vaults on Ubuntu 22. Let's start the lesson by updating and upgrading the packages on the system. So let's execute sudo apt update. Next, we need to sudo apt upgrade -y. Now we have updated and upgraded the packages on the system. The next step is to install Golang. Vaults requires Golang 18 or newer, so I will install version 1.21. Let's download the tar.gz file for Go using the wget command. Now let's extract the gz file to /user/local using tar -c capital, then /user/local -xzvf, then the gz file name. The next step is to export the Go binary path. So let's execute echo, then export path, then the path to the binary directory for Go, and we will append that to .profile file. We also need to export the Go path. So let's execute echo export Go path to the home directory /Go, then we will append that to .profile. Now let's source .profile. Let's validate the Go installation by executing Go version. And as you can see from the output, Go version is Go 1.21.0. Now that we have Go installed, we are ready to install Vaults. So let's clone the Vaults repository using the git clone command, then the URL to Vaults repository. Now let's change the directory to Vaults directory, and let's install Vaults using make install command. This process may take some time, so I will pause the video and I will come back once it is finished. Now we installed Vaults on the system. Let's copy the Vaults binary file to /user/local/bin. To do so, I will go up one directory to the home directory, and in the home directory you can see the Go directory. To copy the Vaults binary file, let's do sudo cp then go/bin then Vaults to /user/local/bin. Now we can execute the Vaults command from our user Vagrant. So let's type Vaults, then press enter, and as you can see, it shows you the Vaults and its subcommands. Now it's time to install the local database for vulnerabilities. the Vaults team provided two tools which we will install. So let's start with GoVal Dictionary. Let's clone the GoVal Dictionary repo. So I will execute the git clone, then the URL for GoVal Dictionary. Now let's change directory to GoVal Dictionary, and to install the GoVal Dictionary, just type make install. And also this process may take some time, so I will pause the video and I will come back once it is done. We have installed the GoVal Dictionary. Let's go up one directory and let's also copy the GoVal Dictionary binary file to user local/bin. To do so, I will type sudo cp go/bin/goval-dictionary to user local binary. Now let's install the second tool from Vaults, which is Ghost, by cloning its repo. So I will execute git clone, then the URL to the Ghost repository. Now press enter, and let's change directory to Ghost. And to install this tool, I will also type make install. And also the installation may take some time, so I will pause the video and I will come back once it is done. Now we have Ghost installed. Let's go back to the home directory and let's also copy the binary file for Ghost from go bin ghost to user local bin. Now it is time to fetch the local vulnerabilities database using GoVal Dictionary and Ghost. So let's execute GoVal Dictionary, then fetch option. Then I want to download the vulnerability database for Red Hat, and I can specify the Red Hat family versions or releases, which is 7, 8, and 9. So this command will download a local database from all vulnerabilities for Red Hat 7, 8, and 9. Now press enter, and it seems that I misspelled the fetch command, so it should be FETCH. Now press enter, and this process also may take some time, so I will pause the video and I will come back once it is done. So the GoVal Dictionary fetched the Red Hat 7, 8, and 9 vulnerabilities. Let's execute ls, and as you can see, it created the SQLite 3 file for the OVAL. Now it's time to fetch the Ubuntu vulnerabilities, so I will execute the same command, but this time it will be Ubuntu, and I want all vulnerabilities for Ubuntu 18.04, or let's start with 16.04, then 18.04, and 20.04. Finally, I want all vulnerabilities for 22.04, and let's press enter. Now we have downloaded all the OVAL vulnerabilities for Red Hat and Ubuntu. Let's use the Ghost tool to fetch the database for Red Hat vulnerabilities. And as you can see, it will take a while for the first time. So I will pause the video and I will come back once it is done. So it is done for Red Hat. If we executed ls, you will also see the database for Ghost vulnerabilities, or the vulnerabilities that has been downloaded by Ghost. Now let's execute the same command to fetch the Ubuntu. And as you can see, the Ghost will download 46,320 vulnerabilities and it will insert it to the database. That concludes our lesson on installing Vaults on Ubuntu 22. In this lesson, we successfully updated and upgraded our system packages, installed Golang, and set up Vaults along with its necessary components such as the GoVal Dictionary and Ghost. We also learned how to fetch the local vulnerabilities database, which is a crucial step in vulnerability management. And by that, we get to the end of our lesson. Thank you for watching and see you in the next lesson. In our previous lesson, we learned how to install Vaults on Ubuntu. In this lesson, we will configure Vaults to scan remote machines. We will start by creating our main configuration file. So from the terminal, let's type nano config.toml. First, we have our server configuration. So I will type server, and this section tells Valls where and how to connect to the remote server. So let's start adding our first server. So open two braces and type servers dot, then the name of the server you want to connect to, and do your scan using Valls. You can provide a name, but I will provide the private IP for this server. So I will type 10-0-1-174. And you can't provide the IP in the usual format, which is 10.0.1.174, because this configuration will be wrong if you provided dot instead of the hyphen. Now for this server block, let's define its host equal to the IP of the server, and the SSH port, it will be the default port 22. If you have a different port, then you will specify it here in the port setting. Then the user to connect to its SSH. In my use case, the username is Ubuntu. Then the key path, and the path to the private key I will use to connect to the server, which start with 52.209.194.68. So the path to the private key is under /home vagrant.ssh private.bam. Next, let's discuss the vulnerability dictionary configuration. This part is crucial for Valls to understand the vulnerabilities it scans for. So here I will add the oval dictionary section. So let's type oval dict, and I will set the type of the database to SQLite 3. Then I will define the SQLite 3 path, which we have seen together in our previous lesson. So the SQLite 3 path for the oval dictionary, it's under /home/vagrant oval.sqlite 3. Let's do the same with the ghost. So the type will be also SQLite 3, and the SQLite 3 path will be under /home/vagrant/ghost.sqlite3. Now let's save the file. To validate our configuration, let's do Valls config test. And as you see, I got an error message here, failed to find the host in known_hosts file, and it provides the commands you can use to add the host to the known hosts file. So let's copy this command and let's provide it to the terminal so that we can add the host 52.209.194.68 to the known hosts file. Okay, now let's validate our configuration once more time with config test option. So we didn't receive any error message, which is a good sign. Now let's execute Valls scan. And as you see, it validated the configuration, and it also detected the server. It detected our server, and it detected the operating system installed on the server, which is Ubuntu 20.04. It also detected that this server is running on Amazon Web Server, and the scan summary, it provides the IP of the server, the operating system or the Linux distribution, and that this server has 600 installed packages. Now to get a report about the server that has been detected from the config.toml file, let's type Valls, then report. And from the shown report, you can see the CVE ID or the vulnerability ID, the severity of the vulnerability. Here you can see that the severity is 9.8, which is critical, and it shows you the packages that has this vulnerability. And you have here a summary that it scanned 186 packages. The critical is 4, high 60, medium 108, and low severity is 14. The Vulse report has many other options, so you can check what options you can use with the Vulse report by executing Vulse report -h. And as you can see from the output, you can send the report to Slack, you can send it to SS3, you can send it to local file, you can send it to Telegram. You can also use -CVSS-over with a score or a severity to get a report for a specific vulnerability severity. So let us assume that you want to display only the critical vulnerabilities. Let's see how we can do that. So we will execute Vulse report, then -CVSS-over. Then I want all vulnerabilities with the score 9 and above. Press enter. As you see, the report only shows the critical vulnerabilities, which is with 9 score or above. Now let's add another server to our configuration to scan. So I will edit the config.toml file, and from the server section I will add another server block. So let's type here servers and this time I will provide a name, not an IP. So I will call this one web server-example-com. Then let's copy the host, port, user, and key path. And here I will change the host to be the IP for web server host, and the user here is Rocky. And I will use the same private key to connect to this server using the user Rocky. Also, let's add a section to the Slack so that we can send the alerts to Slack. To do so, let's add a new section, Slack, then let's provide the hook URL, then the channel, and provide your Slack channel. In our use case, it's ops-alerts. Then provide the user, so I will type here Adam. In our new configuration, we added the Slack section so that we can scan our targets, then send the report to Slack. Also, we have added a new server or virtual machine or host to be scanned by Vulse. So I added here a new section or a new server block for web server example.com with its information like the host, port, user, and key path. Let's save our configuration and let's do Vulse scan. And as you can see, I got an error message because it failed to find the host. So like each time you add a server, you need to add the host to the known hosts. So let's execute this command and let's do Vulse config test to test our configuration. So it's a good practice whenever you change or modify the config.toml file to do first Vulse config test to test your configuration. And I misspelled Vulse, so let's do Vulse config test. And as you see, it detected the web server example.com, and it also detected the Linux distribution, which is Rocky, and the release is 8.9. Now let's do Vulse scan, and we received an error, failed to detect and install DNF modules. And you will see this error with all Red Hat families like Red Hat, CentOS, and also Rocky, because before you scan Red Hat, CentOS, and Rocky with Vulse, you need to execute some commands on the target machine. So let's see how we can do that. So let's connect to the Rocky virtual machine using our private key, then Rocky user, and add the IP of Rocky virtual machine. Now we are inside Rocky virtual machine and we need to execute the following command: sudo yum install yum plugin changelog yum utilities -y. And as you see, the package is already installed. We also need to do sudo sh-c echo package management history command equal yum history info, and we will append this string to /etc/sysconfig/false. We will execute our third and last command, which adding the package management history all equal true to the vals file, which is under sysconfig. Now let's exit the Rocky virtual machine and let's execute the vals scan, and it should work properly this time. And as you see, it worked fine. In the scan summary, I can see the first virtual machine, which is Ubuntu 20.04. We have the second virtual machine, which is web server-example-com, which has Rocky 8.9, and there are 454 packages installed and 36 updatable. Now let's execute vals report to generate our report for the two virtual machines. And from the output of the report, you can see the report for web server example.com. You have 2 critical, 78 high, 139 medium, and 14 low. And if you scroll up, you will find the same for the first virtual machine. So here we have the summary for the first virtual machine. Now let's execute vals report -cvss-over9 to only get the critical vulnerabilities for the two virtual machines. And as you can see, for the web server example.com, we have 2 critical. You can see the CVE ID, the severity, which is critical, the attack, and if it has a fix or not, and the packages that affected with this vulnerability. Now to send this report to Slack, I will just execute the same command, then -2 -slack. Let's press enter and let's validate our work by bring the Slack channel here. And as you can see in the Slack channel, I received the alert for the first virtual machine. If I scroll down, I will see the alert from vals for the second virtual machine. And by sending alerts to Slack from vals, we got to the end of our lesson. Thank you for watching and see you in the next. Hello and welcome to our assignment for the Antivirus and Vulnerability Management project. So we have learned together how to install and configure vals, and also we have seen how to use the vals report to get the vulnerabilities with a specific score. In this case, I want the score 7 and over, and also to send the report to Slack. So your assignment for this project is to add this command to a cron job that will be executed every 15 days at 12 a.m. to send the vulnerabilities with score 7 or higher to Slack. Thank you and happy assignment. Hello everyone and welcome back. This lesson marks the conclusion of our practical lessons on the Antivirus and Vulnerability Management project. Over the course of this project, we have accomplished a great deal together. Firstly, we successfully deployed and managed antivirus software, a crucial step in ensuring the security of our Linux environments against malware threats. Through this process, we delved into the installation and configuration of ClamAV, conducted comprehensive system scans, and established real-time scanning and notifications. These skills are vital in maintaining a robust defense against evolving malware. Moving on to our second major task, we tackled managing system vulnerabilities. This task was pivotal in maintaining high security and compliance standards. We learned how to install and configure vals, perform detailed vulnerability scans, and analyze reports effectively. These actions are essential for identifying and mitigating potential security risks. Now that we have completed this project, you have gained valuable hands-on experience. You are now equipped with the knowledge and skills to build and maintain a strong antivirus and vulnerability management platform for Linux environments. This expertise is not only crucial for protecting your company's data and resources, but also positions you as a key player in the field of cybersecurity. I hope you found these lessons informative and engaging. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on network file system. In this presentation, we will explore the key concepts of NFS, its benefits, architecture, mounting process, export configuration, and use cases. First, let's start with the introduction. Network file system is a distributed file system protocol that enables users on client computers to access files over a network. Originally developed by Sun Microsystems in 1984, NFS has become a widely adopted protocol in Unix and Linux environments. Let's talk about the benefits of NFS. NFS offers several advantages over traditional file sharing methods, including centralized file storage. NFS eliminates the need to maintain multiple copies of files on different machines, streamlining file management and reducing storage space requirements. Improved accessibility. NFS allows users to access files from anywhere on the network, fostering collaboration and productivity. Reduced administrative overhead. Centralized file management with NFS simplifies administration tasks and minimizes the need for manual file synchronization. Let's move to the architecture of NFS. NFS comprises three key components. NFS server. The NFS server provides file access services to client machines. It manages file permissions, handles file requests, and maintains file consistency. Then we have NFS clients. Client machines can access files stored on NFS servers. They initiate file requests, receive responses, and update their local file systems accordingly. The last component is the network. The network connects NFS servers and clients, enabling communication between them. It provides the infrastructure for file requests and responses to travel between the parties. Now let's discuss mounting NFS volumes. Mounting an NFS volume involves attaching an NFS share to a local directory on a client machine. This makes the files on the NFS share appear as if they are stored locally, allowing clients to access and manipulate them seamlessly. So what is the mounting process? First, client mount request. The client initiates the mounting process by executing the mount command. Second, NFS server response. The NFS server receives the mount request, validates the client's credentials, and sends a response containing file system information. Local directory creation. The client creates a local directory to represent the mounted NFS share. Finally, the client-server connection. The client connects to the NFS server and establishes a connection for file access. Now to the configuring NFS export. NFS export refers to the process of making an NFS share available to clients. This is typically done by configuring an NFS export file, which specifies the directory to be exported, the allowed clients, and additional configuration options. What are the export file components? The first component is export path, which is the directory to be exported as an NFS share. Client host names or IP addresses. The list of client machines allowed to access the NFS share. The last component is export options. Additional configuration settings such as permissions, security requirements, and access control lists or ACLS. Now let's discuss the use cases for NFS. NFS finds applications in various scenarios, including file sharing among Unix/Linux systems. NFS is commonly used to share files and folders between Unix/Linux systems, enabling efficient file access and collaboration. Accessing file servers from remote locations. NFS allows users to access files stored on NFS servers from remote locations, promoting remote work and collaboration. Collaborative work on shared files. NFS enables multiple users to work on shared files simultaneously, ensuring data consistency and collaboration. Finally, centralized storage for web applications. NFS provides a centralized storage solution for web applications, facilitating efficient file access and management. Now, let's move to the conclusion of this presentation. NFS has emerged as a reliable and efficient file sharing solution, widely adopted in various IT environments. Its centralized file storage, improved accessibility, and reduced administrative overhead make it a preferred choice for network file sharing. From file sharing among Unix/Linux systems to remote access and collaborative work, NFS caters to a diverse range of use cases. With its continued development and support, NFS remains a crucial technology for distributed file sharing in modern networks. And by that, we get to the end of this presentation. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on backup methods in Linux. In this presentation, we will discuss the different types of backups, backup tools, and strategies for protecting your data in a Linux environment. I hope you find this presentation informative and helpful. Let's start with the introduction to backups. Data backups are essential for protecting your valuable information from accidental deletion, hardware failures, malware attacks, and other disasters. By regularly backing up your data, you can ensure that you have a copy that can be restored in case of an incident. Establishing a backup strategy is crucial for any Linux system, regardless of its size or complexity. Now let's talk about full backups. Full backups create a complete snapshot of all your data at a specific point in time. These are the most comprehensive type of backup, but they also require the most storage space. Full backups are typically performed less frequently than other types of backup, such as incremental or differential backups. Now let's move to the incremental backups. Incremental backups capture only the changes that have occurred since the last full backup. This significantly reduces the amount of data that need to be backed up, making incremental backups more efficient than full backups. However, incremental backups can become cumbersome to manage over time, as they require keeping track of multiple backup points. Now let's talk about the differential backups. Differential backups capture the changes that have occurred since the most recent full backup. This offers a balance between the efficiency of incremental backups and the flexibility of full backups. Differential backups are less space consuming than the full backups, but require more storage space than incremental backups. Let's move to the backup tools, which we will deal with, like tar and rsync. tar is a versatile archiving tool that can be used to create and manage backups. It can create tarballs, which are archives of multiple files and directories. rsync is a fast and efficient tool for copying and syncing files and directories. It can be used to create backups of directories or to synchronize files between different systems. How to choose the right backup method? The choice of backup method depends on several factors, including the volume and the frequency of changes to your data, the availability of storage space, and your recovery time and point objectives. Full backups are the most comprehensive but also the most space intensive. Incremental backups are more efficient but require careful management of multiple backup points. Differential backups offer a balance between efficiency and flexibility. Consider using commercial backup software such as Bacula or Amanda for more complex backup scenarios. These tools offer features such as centralized management, scheduling, and data deduplication. Now let's move to the backup schedule and policies. Establishing a regular backup schedule is crucial for ensuring the protection of your data. The frequency of your backups should align with your RTO and PRO requirements. Develop clear backup policies that define the frequency, storage location, and retention periods for your backups. These policies should be documented and reviewed regularly. Store backups off-site to protect them from physical disasters such as fire or flood. Consider using cloud-based backup services for easy access and redundancy. Let's discuss the disaster recovery planning. Disaster recovery planning is an essential part of any backup strategy. It involves identifying potential disasters, developing contingency plans to mitigate their impact, and testing backup and recovery procedures regularly. Your disaster recovery plan should outline the steps to be taken in the event of a disaster, including data recovery, system restoration, and business continuity. Regularly test your disaster recovery plan to ensure that it is effective and up to date. This will help you stay prepared for any unforeseen event. Now to our conclusion. Data backups are an essential part of any IT infrastructure. By implementing a comprehensive backup strategy, you can protect your valuable information from loss or corruption. Remember, backups are only effective if they are regularly tested and reviewed. Make backup and recovery a regular part of your IT operations to ensure that availability and integrity of your data. And by that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson where we will be covering two essential Linux server tasks, implementing an NFS server and developing an offsite backup strategy. First, let's dive into the NFS server. NFS, or Network File System, is a protocol allowing Linux servers to share files over a network. In this task, you will learn how to set up and configure an NFS server. This includes installing NFS packages, configuring shared directories, and setting appropriate permissions. We will also cover how to mount these shared directories on client systems. This is crucial for networked environments where file sharing is key. Next, let's delve into offsite backup strategies. Remember, in data management, backups are not just essential. They must be secure and located away from the primary data source. In this segment, you will master three types of backups: full, incremental, and differential. First, we will explore full backups using the tar command. This method captures every file and folder, providing a complete snapshot of your data at a specific point in time. While comprehensive, it is storage intensive and not always practical for frequent backups. Next, we will dive into incremental and differential backups using rsync. These methods are more storage efficient. Incremental backups save changes made since the last backup, whether that's the last full or incremental backup. On the other hand, differential backups capture changes made since the last full backup, regardless of any incremental backups in between. Finally, we will bring these concepts together by developing a shell script. This script will automate your backup process, sending your data securely to a remote backup server. By the end of this lesson, you will not only understand these backup methods, but also how to implement them effectively in a real-world Linux environment. Both these tasks are integral in managing Linux servers effectively. By the end of these lessons, you will have a strong grasp on both sharing resources efficiently in a Linux network environment and ensuring data safely through robust backup strategies. And by that, we get to the end of this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on installing and configuring an NFS server. This lesson will guide you step by step through the process. Let's get started. First, we need to access our NFS server virtual machine via SSH. Once connected, the first step is to update your package lists to ensure you have the latest versions of software. Type in sudo apt get update and press enter. Next, we will install the NFS kernel server package. This package enables your virtual machine to act as an NFS server. Type sudo apt get install nfs-kernel-server. With the NFS server installed, it is time to configure NFS exports. This involves setting up a directory that you want to share over the network. Let's create a directory named /var/nfs/general. Type sudo mkdir/var/nfs/general -p. The -p flag ensures that any necessary parent directories are also created. Now assign ownership of this directory to a non-privileged user to enhance security. Type sudo chown nobody for the user, then no group for the group, then the path to the NFS shared folder, which is /var/nfs/general. Next, open the exports configuration file by typing sudo nano/etc/exports. This file will define which directories are shared and with whom. In the file, add the following line. This line specifies the shared directory and the network range allowed to access it. Save and close the file. Now export the shared directory by typing sudo export fs-a. Finally, restart the NFS service for the changes to take effect. Type sudo systemctl restart nfs-kernel-server. Also, let's enable the service so that it can start automatically when the system boot. So I will execute sudo systemctl enable nfs-kernel-server. Great job! You have successfully set up your NFS server, but let's make sure everything works. On a client machine, which can be another virtual machine, install NFS client packages by typing sudo apt-get install nfs-common. Now create a mount point for the NFS share with sudo, then mkdir -p/mnt/nfs/general. Now let's change the owner and the group for this directory to be user vagrant and group vagrant. To do so, type sudo chown -r vagrant dot then /mnt nfs general. Now let's mount the shared directory from your NFS server. So let's edit the fstab file by typing sudo nano/etc fstab. Then provide this line. Here is what each field means. So the 192.168.56.111 is the IP address of your NFS server, and /var/nfs/general is the path of the shared directory. Then we have /mnt/nfs/general, which is the mount point on your client machine. The NFS is the type of the file system, then the permission read-write, and The dump option usually set to 0, which means the file system won't be backed up, and the pass option, which affects the order of file system checks at boot. For NFS, it is typically set to 0. Now let's save the file, and to apply the new configuration inside etc fs tab, type sudo mount -a. Finally, verify the mount by typing df-h, and as you can see, we have our NFS shared listed. Now let's create a file inside the NFS shared directory. So let's type echo, then hello, and I will redirect that to /mnt nfs general, then hello.txt. And there you have it. You have successfully installed and configured an NFS server and tested the NFS share. This setup allows for efficient and easy file sharing across your network. Thank you for following along in this lesson. Stay tuned for more lessons on network file systems and other topics to enhance your skills. Welcome back to our lessons on storage management and network file systems. In this lesson, we are going to install LVM or Logical Volume Manager and share it using NFS. Let's dive in. First, we will install the LVM2 package. This package is essential for managing logical volumes. From your terminal, type sudo apt install LVM2 and press enter. As you see, LVM2 is already installed on our system. With LVM2 installed, the next step is to initialize physical volumes. These are the storage devices that LVM will manage. Execute sudo bvcreate /dev/sdb, then /dev/sdc. This command initializes 2 disks as physical volumes. From the output, as you can see, the physical volume SDB successfully created and also the physical volume SDC successfully created. Now let's create a volume group. Think of this as a pool that combines the storage capacity of the physical volumes. Type sudo vgcreate vg_nfs /dev/sdb /dev/sdc to create a volume group named vg_nfs. From the output, the volume group vg_nfs successfully created. Next, we will create a logical volume within our volume group. This is the portion of the pool that we will actually use. Type sudo lvcreate -n lv_nfs -l 10g, then vg_nfs to create a logical volume named lv_nfs with a size of 10 gigabytes. From the output, logical volume lv_nfs has been created. It's time to format this logical volume. We will format it with the ext4 file system using sudo mkfs.ext4 /dev/fg_nfs /lv_nfs. The file system has been created. Let's copy the UUID for this file system. And also, in case you wanted to list all the UUID for all file systems, simply type sudo blkid and you can get the UUID from here. Now let's create a directory where this volume will be mounted. So let's execute sudo mkdir /nfs_storage. Now let's mount the volume from the fstab file. So let's edit the fstab by executing sudo /etc fstab. And don't forget to provide your editor. I will use the nano here. And let's add this line. So first I provide the UID for the volume, then the mount point we have created, which is nfs_storage, then the file system we created, which is ext4, then defaults 00. Now let's save the file, and to apply the changes, type sudo mount -a. To validate our work, let's type df-h, and as you can see here, the /dev mapper vg_nfs -lv_nfs is mounted to nfs_storage. Now let's share our LVM via NFS. So let's add the LVM mounted directory to /etc/exports. So let's type sudo nano /etc exports. Then here I will provide the mount point, which is /nfs storage. Then I will copy the same IP with the permissions. Let's save the file and let's execute sudo export fs -a to apply our changes, and also let's restart the NFS kernel server service. Now let's go to the client and let's make a directory here with the name shared_dir, and let's add the NFS mount point to the FS tab on the client virtual machine. So let's do sudo nano /etc fs tab. Then let's provide this line, which is similar to the previous one. Now let's save the file and let's apply our changes by executing sudo mount -a, and to validate our work, let's do df-h. And as you see, our logical volume, which we created and shared through the NFS, shown here, and it's mounted to shared_dir. And there you have it. You have successfully installed and configured LVM and shared it over the network using NFS. Thank you for joining this lesson. I hope you found it informative. Stay tuned for more advanced topics in our upcoming lessons. Welcome back. In this lesson, we are diving into RAID technology. RAID, or Redundant Array of Independent Disks, is a data storage virtualization technology that combines multiple physical disk drive components into a single logical unit. Let's get started with setting up a RAID 1 array and sharing it via NFS. First, we need to install the necessary RAID tools. Open your terminal and type sudo apt-get install mdadm. This command installs mdadm, a utility for managing RAID arrays. Now let's create our RAID 1 array. RAID 1 is all about mirroring data for redundancy. Type sudo mdadm --create -verbose /dev /md0 -level = 1 -raid -devices = 2 /dev /sdd /dev /sde. This command creates a new RAID 1 array named md0 using two disks /dev /sdd and /dev /sde. The system confirm continue creating array, so let's type yes. Next, we need to update the mdadm configuration file. This step ensures that the RAID array is properly recognized by the system. Type sudo mdadm -detail -scan, then pipe to sudo t-a /etc/mdadm/mdadm.conf. With our RAID array created, it's time to format it. We will use the ext4 file system. So let's type sudo mkfs.ext4 /dev /md0. Now our file system has been created. Let's copy the file system UUID. Let's create a directory where we will mount our RAID array. Type sudo mkdir /raid_storage. Now let's mount the RAID array from the FS tab. So let's edit the FS tab file. To do so, I will execute sudo nano /etc fs tab. Then, similar to what we did with the LVM, let's add a new line for the RAID storage. let's save the file and let's apply our changes by executing sudo mount -a. To validate our work, let's execute df-h, and as you can see, our RAID array is now mounted to /RAID_storage. Finally, let's share our RAID storage via NFS. This process is similar to what we did with LVM. Add the RAID mounted directory to /etc/exports. So let's edit /etc exports, and from here I will provide the mount point for the RAID array, which is /RAID_storage. Then I will copy the same configuration from here. Now let's save the file and let's execute sudo export fs -a to apply our changes. Then we need to restart the NFS kernel server. So I will type sudo systemctl restart nfs-kernel-server. And that's it. You have successfully set up a RAID 1 array and shared it over your network using NFS. Thank you for watching this lesson and see you in the next lesson. Hello and welcome back to our assignment. In our previous lesson, we successfully installed RAID tools and shared the RAID directory using NFS. Now, I would like you to follow a similar process to mount the NFS shared RAID directory on the client VM, just as we did with the LVM. Thank you for watching and happy assignment. Hello and welcome to a new lesson on local backup. In this lesson, we will learn together how to take a backup using different methods on a local machine. Let's roll up our sleeves and get started with the exciting world of Linux backups. Now let's begin with full backups. These provide a complete snapshot of your system. First, let's create a backup directory. So let's execute together sudo mkdir/backup. Now let's change the owner and the group of this directory to Vagrant. Let's execute sudo chown -r vagrant dot then /backup. Then let's take a full backup from the Vagrant home directory to /backup. Let's execute sudo tar -cvpzf then /backup, then the backup file name, which will be vagrant_home_backup.tar.gz. Then the source we need to backup, which is /home vagrant. This command uses tar to compress and archive, while p preserves the file permissions. Let's press enter. Now let's validate that the backup file in /backup. So let's do ls -lh /backup. And as you can see, we have the .tar.gz file, and the size of the file is 2.8 kilobytes. Now let's list the content of the backup .tar.gz file by executing the following command. tar -tvf/backup/ then the backup file we need to list all its content. Now press enter, and from the result you can see all the directories inside this tar file, and also for each directory or file you can see the owner and the group. If you encounter an error about insufficient storage, you will need to either free up space or choose a location with more available space. That's it for full backups. Remember, they can be storage intensive but are invaluable for comprehensive recovery. Moving on to incremental backups. These are efficient for regularly backing up your data by only saving changes since the last backup. Let's see how to implement them. Let's create a directory for incremental backup. So let's execute mkdir/backup/incremental. Now let's take a backup from the Vagrant home directory, but first let's create 3 files. So I will use the touch command to create the files, and the 3 files will be file 1.txt, file 2.txt, and finally file 3.txt. Now let's execute the rsync for the first time to take the full backup. In this command, I added --exclude option because I don't want a backup from the .cache directory. Now let's execute rsync for the first time to take a full backup. As you see from the result, all files and directories in /home/vagrant except .cache have been sent to /backup incremental, then vagrant directory, and the time and the date of the execution of this rsync command. Now let's check the incremental backup directory. So I will copy the directory here, then I will do ls-l, then the path to the incremental backup directory. As you see, we have a backup of our files here. And if you want to list hidden files and directories, add -a to the command. So the command should be ls-la. And here you can see the files we have created together and the hidden directories or files. Okay, let's only list the files. So I will execute the same command again, but this time I will remove the A option. Now I want you to notice the number 1 here. This number shows how many hard links point to the file. In this case, the number is 1, which means there are no other hard links to those files. Now let's execute the rsync command one more time. This time I have added --link-dist to the rsync command. This is an advanced option. --link-dist tells rsync to compare the source files with the files in the specified directory /backup/incremental/latest and use hard links for files that are identical. This saves space because instead of copying identical files, it creates hard links, making this method efficient for incremental backups. Now let's execute the command. Now after each backup, using the --link-dist, you need to update the latest symlink to point to the new backup directory. So let's copy the new backup directory path and let's execute the following to create the symlink. So I will type ln -sfn, then the path to the incremental backup directory, then /backup/incremental/latest. Now let's do ls-ld/backup incremental latest. And as you see, the latest is a symlink from /backup/incremental, then vagrant-date and time directory. Let's execute the same command, but this time I will remove the D option and I will also add a slash here. Now press enter. We can see our files and the count number for hard links is still 1. Now let's create a new file. So I will type touch file4.txt. Also, let's edit file1.txt. So I will do nano file1.txt and I will just type here hello. Let's save the file. Now let's execute the rsync one more time. As you see, a new incremental backup directory has been created and it sends the newly created file 4.txt to the backup directory. Now let's copy the created directory, the newly created directory for incremental backup, and let's create a symlink with ln -sfn, then the path we just copied, then /backup incremental latest. The next step is to execute ls-l/backup incremental latest and don't forget the slash. As you see now, the count number for hard links has changed as expected. The files that are identical have the count number 2. They are not copied to the backup directory, but instead point to the same physical data on the disk without duplicating the data. rsync only copied the files that have changed, either if they are newly created file as file4.txt or have been modified as file1.txt. Now let's move to the differential backup. So let's execute mkdir/backup/differential to create a new directory for our differential backup. Now let's run the rsync command. As you see, it sends Vagrant home directory files and directories to /backup/differential. Let's execute ls-l/backup differential, then press enter. As you see, we have all our files listed here. Notice the count number of hard links. Let's create a new file and modify file4.txt. To create a new file, I will just type touch file 5.txt and let's edit file 4.txt and I will just type here hello. Now let's save the file. Let's execute the rsync command again. As you see from the output, it sends the newly created file and also the file we have modified. Let's execute ls-l again. As you see, we have our newly created file and also from the count number of hard links for all is 1, which means differential will always have a copy of files and it won't save space. To summarize the difference between incremental and differential backup, we can say differential backup copies all changes made since the last full backup, always referencing the original full backup, while incremental backup copies only the changes made since the most recent backup, whether full or incremental. And with that, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Welcome back to our Linux backup lessons. In this lesson, we are diving into automating offsite backups. Let's start by setting up a remote Linux server and configuring SSH for secure transfers. First, let's generate an SSH key pair on our local machine. So from the terminal, execute ssh-keygen -t rsa. I will save the file to /home/vagrant.ssh/id_rsa. I will not provide any passphrase, so I will just press enter twice. Now let's copy the public key to our remote server, which is our backup server, using the ssh-copy ID, then the user on the remote server, then the IP of the remote server. Now press enter and type yes. Now provide the password for user Vagrant on the backup remote server. And as you can see, number of keys added is 1, and also we can validate our work. So let's connect to the remote backup server using the SSH command, then the user and the IP. Now press enter, and as you can see, I managed to log into the backup virtual machine, which we will use as the remote backup server. Let's exit. Now let's explain our script that will automate the backup process from the client virtual machine to the remote backup server. In this script, we first set up a few variables. Remote user is your username on the remote server. Here it is set to Vagrant. Remote host is the IP address of the server, in this case 192.168.56.114. Then we have remote dir, which is where you want your backup stored on the remote server. For us, it's /backup. Finally, source_dir specifies the local directory you want to backup. Here it is /home/vagrant. These variables make the script easily customizable. Now let's talk about the heart of this script, the rsync command. rsync -avz -e ssh is a powerful combo. The -a flag ensures archival mode, which preserves permissions, timestamps, and more. -V stands for verbose, giving you detailed output of the process. -Z compresses data during the transfer, speeding things up, especially for large files. The -E SSH part specifies secure shell SSH for data transfer, adding a layer of security. The script then syncs everything from source dir to the specified remote dir on your remote server, with all activity logged into /temp/backup.log. It's efficient and secure, exactly what you need for hassle-free backups. Lastly, let's not forget about error handling. The script checks the exit status of rsync command. If it returns 0, it means the backup was successful, and you will see a comforting backup successful message. If not, it echoes backup failed and exit with a status of 1. This is a simple yet effective way to ensure that you are immediately aware of any issues with your backup process. Okay, now let's go back to our terminal. So I will go back to the backup server and let's create together the /backup directory. So let's execute sudo mkdir/backup. I will also change the owner and the group for this backup to user Vagrant. So let's execute sudo chown -r vagrant dot then /backup. So now we have created our remote directory. Let's go to the client virtual machine, and from here I will execute sudo mkdir/scripts to put my shell script inside it. And also I will change the owner and the group for /scripts to user Vagrant. So let's execute sudo chown -r vagrant dot then /scripts. Now let's create our script file, which will be under scripts remote _backup.sh. Now press enter and let's copy the script from my local machine and let's paste it here. Okay, now let's save the file and let's change mode, then give executable permission to /scripts /remote _backup.sh, and let's test the script. So let's execute /scripts remote backup.sh, and as you can see, the backup successful, so all looks good. We can check the backup log from /temp/backup.log, and as you can see, it will print the output of rsync command. Now let's go to the backup virtual machine and let's do ls-l/backup, and as you can see, we have the Vagrant home directory here, and the rsync preserved the permission of it for the owner and the group, and also the permissions of the directory itself. Next, let's schedule our backup. So let's go back to the client virtual machine and let's from here execute cron tab -e, and I will choose the nano as editor for cron tab. So I will type 2 and press enter, and let's add this line here 02 ****, then the path to our script, which will be /scripts remote _backup.sh. So this line will ensure that the backup will run every day at 2 a.m. Let's save the cron tab, and now let's restart the cron service by executing sudo systemctl restart cron. And we always restart the cron service after we edit the cron tab to ensure that our modification has been applied. That's it. You have automated offsite backups with logging. And by that, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Hello again. Let's quickly recap the key points we have covered in implementing NFS servers and developing offsite backup strategies in Linux. We started by setting up an NFS server, a critical component for file sharing in Linux networks. We went through installing NFS packages, configuring shared directories, and setting permissions. Remember, the goal here is to ensure seamless and secure access to shared resources across different systems in your network. Then, we moved on to the crucial task of creating offsite backups. We discussed the importance of different backup types, full backups using tar for complete snapshots, and incremental and differential backups using rsync for efficiency. More importantly, we learned how to automate these backups with a shell script, ensuring our data is not only backed up but also secure and recoverable in any scenario. Mastering these skills is essential for any Linux administrator. They ensure not only the efficient operation of your network, but also the safety and integrity of your data. Keep practicing these techniques and you will be well on your way to becoming a proficient Linux server administrator. Now, since we have completed the two tasks together, let's move them from the in progress to done. And by that, we get to the end of this project. Thank you for watching and see you in the next project.